Imagine drifting through a vast, silent canvas of pure, glowing hues, completely untethered from the heavy demands of the waking world. Starlight is gently illuminating microscopic grains all around you, transforming the infinite dark void into a breathtaking watercolour of soft blues and deep violets. This is the hidden, delicate mist of interstellar material, waiting patiently in the shadows for the brilliant radiation of a newly ignited sun to reveal its quiet beauty. Picture a hidden sanctuary where the universe itself holds its breath, woven securely together by an invisible, majestic magnetic tapestry. Within these peaceful, sheltered places, a heavy, hushed stillness begins to settle over the vast, dark molecular clouds. It is a profound, prenatal silence that perfectly mirrors the heavy, expectant tension of the air just before a gentle, soothing summer rain. Surprisingly, the sweeping, patient journey of these ancient voyagers perfectly matches the slow, steady rhythm of your own resting body. As you sink deeper into the mattress, feel the comforting, familiar weight of the blankets grounding you in this quiet room. You are safe. This cosmic structure is a masterpiece of ultimate patience, seamlessly turning the fading light of one story into the beautiful beginning of another. As your eyes grow heavier and your breathing slows to a peaceful hum, let your mind drift outward into that grand, never-ending current. The journey of a dust grain is cyclical, moving endlessly between the hearts of dying stars and the birthplaces of new worlds. Starlight gently illuminating microscopic grains creates the breathtaking colours we see in reflection nebulae, transforming the dark void into a canvas of soft, glowing hues. When the brilliant radiation from a newly ignited star pushes outward, it encounters a fine mist of interstellar material drifting through the cold cosmos. Instead of simply absorbing this immense energy, the delicate particles catch the light, scattering it across the vast distances of empty space. This cosmic interaction mirrors the way sunlight filters through a hazy morning atmosphere, but on a scale that spans countless trillions of miles. The shorter, bluer wavelengths of starlight bounce erratically off the irregular surfaces of the dust, creating a luminous azure glow that appears to pool around the stellar source. Observers gazing into the deep universe are treated to a spectral masterpiece, a quiet testament to the pervasive presence of invisible matter. Deep within these glowing veils, the hidden architecture of the galaxy reveals itself through a majestic interplay of illumination and shadow. A reflection nebula does not burn with its own fiery fusion. Rather, it serves as a magnificent mirror. It captures the fierce vitality of a neighbouring sun and softens it into a tranquil radiance, allowing us to witness the subtle substance that forms the foundation of future worlds. Surprisingly, the universe contains endless clouds of silicate dust, resembling fine sand floating in a grand cosmic ocean. Long before planets coalesce into solid spheres of rock and magma, the raw ingredients of geology drift freely through the immense expanse of the interstellar medium. These silicates, forged in the dying breaths of ancient stars, are fundamentally similar to the quartz and sand found on terrestrial beaches, yet they exist as isolated, microscopic specks suspended in a near-perfect vacuum. If we were to look closer at these sprawling clouds, we would find a serene, almost ghostly environment where gravity has not yet gathered the scattered grains into dense bodies. The sheer volume of this drifting material is staggering, forming sweeping currents that stretch across hundreds of light years. It moves with a glacial, hypnotic grace, driven only by the gentle pressure of starlight and the subtle pull of distant galactic structures. This drifting cosmic sand forms the invisible framework upon which the visible galaxy is draped, quietly waiting for the spark of gravitational collapse. Without these endless, hazy oceans of silicates, the universe would be entirely devoid of rocky worlds, mountains, and continents. They are the patient seeds of terrestrial planets, drifting through an eternal night until the forces of nature orchestrate their grand convergence. Deep within these glowing veils, carbon-rich particles absorb harsh, ultraviolet radiation and re-emit it as a soothing infrared glow. The raw, unfiltered energy tearing through space from young, massive stars is fiercely destructive, capable of stripping electrons and shattering fragile molecular bonds. Yet, the fine mist of interstellar dust acts as a remarkable cosmic shield, catching these lethal ultraviolet photons before they can wreak havoc on the surrounding molecular clouds. This microscopic soot, composed of intricate carbon molecules, possesses the unique ability to safely process the blistering energy of the cosmos. As a grain absorbs a high-energy photon, it briefly vibrates with intense heat, only to immediately cool down by radiating the energy away at much longer, gentler wavelengths. This continuous thermal transformation turns an invisible bath of lethal radiation into a soft, warm luminescence that permeates the shadowy nurseries of the galaxy. Notice how this crucial mechanism protects the delicate chemistry, occurring deeper within the dark clouds, fostering an environment where complex organics can safely assemble. Infrared telescopes peering into these regions do not see the blinding glare of the stars, but rather the collective radiant warmth of trillions of tiny glowing embers. It is a harmonious energy exchange, turning the violent outbursts of stellar giants into a comforting radiant pulse. This structure of microscopic soot and sand is responsible for the dark, majestic silhouettes like the Horsehead Nebula. When observed against a brilliantly illuminated background of ionized gas, these dense concentrations of dust appear as towering, pitch-black monuments rising from the cosmic floor. They are not absences of light or empty voids in space, but rather thick, impenetrable walls of matter that completely block the glowing hydrogen behind them. Picture a heavy bank of fog rolling in to obscure the bright lights of a distant city, muting the brilliance until only dark shapes remain. The interstellar dust grains within these pillars are packed closely enough together to intercept nearly every photon of visible light attempting to pass through their ranks. The resulting visual contrast is breathtaking, carving sharp, evocative profiles out of the glowing celestial mist. These dark nebulae are the cold, brooding titans of the galaxy, holding vast reservoirs of raw material in a state of suspended animation. Their imposing shapes are slowly sculpted over millennia by the harsh winds and intense radiation of nearby stars, eroding the outer layers while the dense cores stubbornly resist. Within the profound darkness of these majestic silhouettes, the very next generation of stars is secretly beginning to take shape. Imagine gazing at the Milky Way on a clear night. The dark patches are not empty space, but vast rivers of obscuring dust. For centuries, skywatchers believed these blackened rifts dividing the starry band were true holes in the heavens, mere windows looking out into the absolute nothingness beyond our galaxy. In reality, they are sweeping lanes of microscopic particulate matter, acting as an immense, opaque curtain drawn across the blazing heart of the galactic centre. This cosmic fog settles heavily along the central plane of our spiral galaxy, accumulating in the spaces between the sweeping starry arms. As the combined light of billions of distant suns attempts to travel across the galaxy to reach our eyes, it is swallowed by this intervening mist of carbon and silicates. The dust acts as a master of illusion, hiding the true, overwhelming brilliance of the Milky Way behind a fragmented, mottled facade. If we were to look closer at these dark rivers using specialized infrared instruments, the seemingly empty voids would burst into vibrant, heat-radiating life. The obscuring dust maps out the densest, most fertile regions of our local universe, tracing the swirling, interconnected currents of interstellar material. What appears to the naked eye as a barren absence is actually the most tangible, physical presence in the night sky. Each individual grain is smaller than the wavelength of visible light, yet together they can hide entire galaxies from our view. The sheer scale of this paradox is staggering when one considers that a single speck of cosmic dust is barely a fraction of a micron across. They're so infinitesimally small that a photon of red light can easily step right over them, completely undisturbed by their minuscule physical presence. However, the true power of the interstellar medium lies in its incomprehensible numbers, forming a collective barrier of unimaginable proportions. When these microscopic specks are distributed across thousands of light years, their combined cross-section becomes an impassable wall for any visible radiation attempting a long cosmic journey. A beam of starlight might travel uninterrupted for centuries, only to be absorbed by a tiny jagged flake of carbon mere moments before it would have cleared the cloud. Surprisingly, this microscopic haze is powerful enough to heavily obscure our view of the universe beyond the Milky Way's disk, creating the so-called zone of avoidance. Entire clusters of galaxies blazing with the light of trillions of stars are rendered completely invisible to optical telescopes simply because they lie behind this dusty veil. It is a humbling reminder that the grandest structures in the cosmos can be entirely humbled by the smallest. Notice how scattered blue light makes the Pleiades star cluster look like it is wrapped in a delicate wispy cobweb. As the brilliant hot stars of the Seven Sisters plough through a completely unrelated cloud of interstellar dust, their intense luminosity illuminates the wandering grains. The resulting visual effect is a haunting ethereal glow that seems to cling to the stars like threads of spun glass catching the morning dew. This delicate netting is entirely transient, a fleeting moment of cosmic alignment where the trajectories of a stellar cluster and a roaming dust cloud happen to intersect. The dust itself is not bound to the stars by gravity, but is merely passing through the intense radiation field as it drifts through the torus molecular cloud complex. The intricate filamentary structure of the cobweb is carved by the magnetic fields and stellar winds pushing against the fine particulate mist. This breathtaking phenomenon beautifully demonstrates how even the most diffuse matter can be brought to vibrant life by the right source of illumination. The scattered starlight reveals the hidden textures of the interstellar void, mapping out the ridges, hollows, and subtle density variations of the passing cloud. It transforms a dark, invisible wanderer into a glowing masterpiece of celestial art for a brief, glorious epoch. Even the spaces between stars are never truly empty, holding roughly one dust grain per every football field of volume. To the human mind, this level of scarcity defines an absolute vacuum, a desolation so profound that it defies terrestrial comprehension. Yet, in the grand calculus of the cosmos, this incredibly sparse distribution of matter adds up to a staggering total mass that profoundly influences the evolution of the galaxy. Picture the sheer vastness of the interstellar void, where distances are measured in trillions of miles and the silence is absolute. A single, solitary speck of ice-coated rock drifts through this unimaginable expanse, separated from its nearest microscopic neighbour by an entire stadium's worth of nothingness. There are no collisions, no gentle grazing of surfaces, just a lonely, endless fall through the dark, cold currents of the galactic plane. This extreme isolation makes the eventual formation of dense clouds and stars all the more miraculous, requiring eons of patient gathering. Over millions of years, the subtle currents of gravity and interstellar magnetism slowly herd these incredibly isolated wanderers closer together. What begins as a solitary grain in a boundless void eventually joins a collective mass capable of birthing entirely new solar systems. If we were to look closer at a single grain, we would see an irregular, fluffy shape coated in a thin mantle of sparkling water ice. Unlike the perfectly smooth spheres often depicted in textbooks, real cosmic dust is jagged, porous, and highly complex in its microscopic geometry. They resemble tiny, chaotic tumbleweeds made of rocky minerals and carbon soot, providing a vast amount of surface area relative to their minuscule volume. This high surface area is a crucial feature, allowing wandering molecules of oxygen and hydrogen to easily latch onto the jagged edges and crevices of the grain. In the freezing depths of deep space, these captured atoms quickly combine and freeze, wrapping the dark core in a pristine, shimmering shell of frozen water, ammonia, and carbon monoxide. The dust particle ceases to be just a piece of grit and becomes a microscopic, icy comet drifting through the long night. Deep within this crystalline mantle, the most profound chemistry of the universe begins to quietly take shape without any fanfare. The frozen layer acts as a catalytic laboratory where simple elements can meet and bond, shielded from the destructive energy of deep space. This sparkling frost holds the vital chemical precursors that will one day seed the oceans of nascent rocky worlds. This silent migration carries the raw materials of creation across unimaginable distances, transporting the ashes of dead stars to the dark nurseries where new ones are waiting to be born. A dust grain forged in the fiery heart of a supernova might travel halfway across the galaxy before finally coming to rest. It is a slow, relentless journey, dictated by the gentle push of radiation pressure and the swirling eddies of galactic magnetic fields. Eventually, this wandering mist will encounter a dense pocket of molecular gas, causing the current to stall and the dust to pool into a heavy dark veil. Here, the long journey of the scattered grains pauses as the forces of gravity begin to weave the drifting clouds into a tighter, heavier shroud. The endless drift inevitably leads to collapse, setting the stage for the explosive ignition of a brand new stellar generation. That explosive ignition of a brand new stellar generation is eventually destined to end in a slow, glowing demise, bringing us to the very birthplaces of the cosmic sand. Deep inside the swelling atmospheres of dying red giant stars, the intense heat that once defined their youth begins to wane, allowing heavy elements to finally cool enough to condense into solid matter. As these swollen, aging titans exhaust their primary nuclear fuel, their outer layers puff outward, expanding millions of miles into the freezing vacuum. In this cooling, tenuous envelope, atoms of silicon, oxygen, and carbon are no longer violently smashed together, but instead begin to seek out gentle chemical bonds. This dramatic shift in temperature creates a localized environment remarkably similar to a cooling kiln, where the gaseous breath of the star solidifies into microscopic grains. The turbulent convection currents boiling up from the dying core carry these newly forged elements outward, lifting them into regions where the chill of space allows them to crystallize. It is here, suspended in the ruby glow of a fading sun, that the first true solid particles of the universe are born. This continuous outward breath of old stars slowly pushes these newly formed particles away, seeding the surrounding void with brand new silicate and carbon flakes. The radiation pressure emanating from the glowing core catches the broad, irregular surfaces of these microscopic grains, acting like a gentle wind against a billion tiny sails. Slowly but inevitably, the solid ash is driven away from the gravitational grip of the parent star, beginning its long journey into the dark expanse. Picture a dandelion releasing its seeds into a steady autumn breeze, dispersing its legacy far beyond its own resting place. The sheer volume of material expelled by a single red giant over thousands of years is staggering, amounting to entire planetary masses of pristine cosmic dust. This steady exhalation ensures that the vast empty stretches of the galaxy are continually enriched with the essential ingredients for future creation. Surprisingly, the composition of these flakes depends entirely on the delicate chemical balance within the dying star's atmosphere. Carbon-rich stars will exhale vast clouds of dark soot, while those dominated by oxygen will breathe out crystalline silicates, resembling microscopic shards of glass. Each star contributes its own unique blend of minerals to the cosmic ocean, subtly altering the chemical makeup of the interstellar medium. As you rest here, allowing your breathing to slow and deepen, feel the quiet weight of your own body, anchored safely while the universe continues its grand, chaotic churning. Beyond the quiet exhalations of red giants, Picture a massive supernova explosion not just as a devastatingly destructive event, but as a brilliant chaotic factory forging exotic dust compounds. When the most massive stars exhaust their fuel, their sudden and violent collapse triggers a rebound of unimaginable power, tearing the star apart in a blinding flash. Within the rapidly expanding shockwave of this cataclysm, conditions are extreme enough to force heavy elements into entirely new, solid configurations. Deep within the fiery cauldron of the supernova remnant, the rapidly cooling ejecta becomes a fertile ground for rapid condensation. The sheer violence of the explosion creates localized pockets of immense pressure and cooling gas, perfect for forging dense, durable materials that could never form in the gentle breath of a smaller star. Here, in the wake of ultimate destruction, the universe rapidly synthesizes rare and complex minerals. This chaotic environment produces grains that are uniquely hardened, forged in the fiercest fires known to the cosmos. They are born in a fleeting moment of ultimate energy, locking away the memory of the explosion within their crystalline structures. The supernova acts as an extreme pressure cooker, briefly existing just to populate the void with the most resilient forms of cosmic matter. The sheer force of these stellar deaths scatters newly formed iron and titanium crystals across countless light years, propelling them through the galaxy at tremendous speeds. The shockwave of the blast acts as an unstoppable cosmic plough, driving the freshly forged dust outward and embedding it deep into neighbouring gas clouds. These heavy metallic grains are the shrapnel of a detonated sun, carrying the rare elements necessary for forming the solid cores of future planets. Notice how this violent dispersal guarantees that even the most isolated, pristine pockets of the galaxy eventually receive a dusting of heavy metals. The expanding bubble of the supernova remnant acts as a massive delivery system, pushing iron-rich fragments far beyond the original stellar neighbourhood. It is a violent but necessary redistribution of wealth, sharing the hard-won elements of the core with the cold, starving voids. If we were to look closer at these metallic micrometeorites, we would find them to be incredibly dense, pure fragments of cosmic iron and titanium. They are the heavy anchors of the interstellar medium, resisting the subtle forces that easily move lighter carbon soot. These durable crystals will endure for eons, waiting patiently until gravity calls upon them to sink into the molten heart of a newly forming world. Surprisingly, some of the dust currently drifting within our own solar system predates the birth of our sun, having been forged in the atmospheres of ancient, long-dead stars. Before our local star even began to coalesce from a collapsing cloud of gas, these resilient grains had already travelled across the galaxy, surviving the harsh radiation and violent shockwaves of deep space. They were swept up in the swirling nebula that eventually formed our planetary neighbourhood, becoming silently trapped in meteorites and comets. These ancient wanderers are completely alien to the current chemical makeup of our solar system, standing out as microscopic anomalies in the local rock. They did not condense in the warm disk of material that built our home, but instead carry the exotic signatures of stellar forges that burned out billions of years ago. Finding one is akin to discovering a perfectly preserved artifact from a lost, forgotten civilization buried deep within your own backyard. Let the tension in your shoulders melt away, sinking deeper into the surface beneath you as you consider the incredible age of these silent, microscopic travellers. Their survival through the eons is a testament to the enduring, unbreakable nature of the most basic building blocks of reality. These presolar grains carry the unique chemical fingerprints of their parent stars, serving as microscopic, indestructible time capsules from an earlier era of the galaxy. By carefully isolating these specks from ancient meteorites, scientists can measure the precise ratios of isotopes locked within their crystalline matrices. These isotopic signatures are so distinct that they can be traced back to specific types of stellar deaths, such as a particular class of supernova or a specific phase of a red giant's decay. Deep within a single grain of silicon carbide, The isotopic ratio of carbon acts like a detailed barcode, revealing the exact nuclear reactions that were occurring inside the star that created it. It is a direct, tangible message from a stellar core that ceased to exist billions of years before the Earth was even a thought. These grains offer an unprecedented physical connection to the ancestors of our solar system. Picture a historian reading an original ancient manuscript. Analysing a pre-solar grain allows us to read the original, unaltered history of galactic evolution. They remain completely unchanged since the moment they solidified, refusing to melt or alter during the violent birth of our planets. They are the ultimate survivors, preserving the exact conditions of their violent birth for eternity. Moving away from the explosive violence, cooling stellar winds surrounding less massive stars allow wandering molecules to clump together lazily, growing atom by atom into sturdy cosmic sand. As the gentle thermal breeze carries gas away from the stellar surface, the temperature drops just enough for random atomic collisions to result in permanent bonds. This is a delicate, unhurried process where a single grain might take centuries to grow to the width of a human hair. Notice the gentle rise and fall of your chest, a steady, calming rhythm that mirrors the slow, continuous processes unfolding in the dark sky above. Interstellar space is constantly replenished by this gentle rain of stardust falling away from aging stellar giants, ensuring the galaxy never runs out of the raw materials for life. As old stars die, they do not simply vanish. They generously donate their newly forged elements back to the communal reservoir of the galaxy. Imagine a vast cosmic autumn, where countless dying suns slowly shed their outer layers like leaves falling into a deep, dark forest. The sheer volume of this gently falling dust is what gradually builds the massive opaque clouds that eventually birth the next generation of stars. It is an exquisite system of recycling, where the end of one stellar life directly provides the physical substance for 1,000 new beginnings. Surprisingly, without this constant dusty drizzle from the older populations, star formation in our galaxy would have ground to a halt billions of years ago. The universe relies on the slow demise of its elders to enrich the void with the heavy elements necessary to build complex solid worlds. It is a beautiful, self-sustaining cycle of birth, death, and dusty rebirth. Observe how the cast-off outer layers of planetary nebulae create expanding bubbles of shimmering dust around the exposed glowing core of a white dwarf. When a sun-like star reaches the very end of its red giant phase, it gently puffs off its entire outer envelope in a sequence of beautiful symmetrical pulses. The dying core, now a fiercely hot dense cinder, floods this expanding shell of gas and dust with intense ultraviolet light, causing it to glow brilliantly. Deep within these expanding halos, the newly forged dust grains are illuminated one final time by the parent star that created them. The intricate shapes of these nebulae, resembling giant cosmic eyes or hourglasses, are sculpted by the interaction of the dying star's winds, pushing against the dusty ejector. The solid particles within the shell are slowly pushed outward by the radiation, creating a hollow, glowing sphere of enriched material. This cosmic structure serves as a brief, glorious monument to the star that once was, before the material eventually diffuses entirely into the dark background. The dust grains in this shimmering bubble carry the very last breath of heavy elements the star will ever produce, a final gift to the surrounding void. Eventually, the brilliant colours will fade and the microscopic ash will merge silently with the cold, wandering currents of the galaxy. Ultimately, every single particle of carbon floating in these vast dark clouds was once forged in the crushing nuclear furnace of a shining star. The universe did not begin with the dark, heavy soot necessary for terrestrial life. The intense dawn of creation produced only the lightest of gases. It required the immense pressure and heat of stellar cores, burning for millions of years, to fuse lighter atoms together into the stable element of carbon. This means that the very backbone of all known organic chemistry, the fundamental building block of life itself, had to be manufactured in the heart of a sun before being violently or gently expelled into the void. The dark, obscuring veils that hide the distant galaxies are constructed entirely of recycled stellar ash. To look upon a cloud of cosmic dust is to look upon the cremated remains of 1 billion ancient suns. If we were to look closer at our own existence, the reality becomes profoundly intimate. The carbon weaving through the cells in your resting body, the calcium hardening your bones, and the iron carrying oxygen in your blood all share this incredible fiery origin. We are quite literally breathing, thinking beings constructed entirely from the scattered, cool dust of dead stars. As those scattered, cooled remnants of dead stars drift further into the deepest, most lightless chasms of the galaxy, they enter realms of unimaginable cold. Far from the warming glow of any nearby sun, the ambient temperature within dense molecular clouds plummets to just a few degrees above absolute zero. In this profound chill, wandering gas molecules lose nearly all their kinetic energy, moving sluggishly through the dark until they inevitably collide with a solid surface. Deep within these freezing shadows, a simple physical process begins to radically alter the nature of the interstellar medium. When a sluggish atom of oxygen or a molecule of carbon monoxide strikes the jagged edge of a silicate flake, it can no longer bounce away, instead freezing directly onto the mineral substrate. This continuous silent accumulation acts like a microscopic snowstorm, gradually burying the original stellar ash beneath layers of volatile gases. Notice how this delicate process requires the utmost stillness and isolation to successfully take hold. The dark clouds serve as massive cosmic refrigerators, carefully preserving the drifting grains while actively stripping the surrounding void of its free-floating gaseous inventory. Over millions of years, the once naked stone and soot become entirely entombed within a pristine frozen shell. This delicate layer of frost transforms the gritty, chaotic structure of the original silica into a smooth, icy pearl drifting silently through the freezing void. What was once a highly irregular, porous fragment with countless sharp edges becomes rounded and smoothed by the accumulating layers of frozen gas. The visual transformation is akin to a jagged tree branch being softened and completely encased by a clear, hard winter ice storm. If we were to look closer at the physical state of this new mantle, we would find it lacks the neat, repeating crystalline structure of regular ice found on Earth. Instead, the extreme cold forces the molecules to freeze instantly where they land, creating a chaotic, amorphous solid that resembles rigid glass rather than a delicate snowflake. This disordered architecture is highly porous, full of microscopic traps and cavities ready to ensnare further passing atoms. Surprisingly, this smooth outer casing radically changes how the particle interacts with whatever faint light manages to penetrate the dark cloud. The icy pearl becomes highly reflective at certain wavelengths, altering its thermal properties and further insulating the dark, ancient stellar ash at its core. It is a beautiful, necessary metamorphosis, preparing the drifting speck for its next crucial role in the cosmic ecosystem. Water, ammonia, and carbon monoxide readily mix within these microscopic ice mantles to create a highly reactive and complex chemical playground. Because the amorphous ice is built through random successive collisions, these different volatile compounds are forced into intimate contact, trapped side by side in the frozen matrix. They form a messy, heterogeneous stew, locked together in a suspended state of potential energy. Picture a frozen laboratory where the raw ingredients for life are carefully measured out and placed into deep freeze, just waiting for an activating spark. The close proximity of these diverse molecules within the icy shell circumvents the extreme emptiness of space, where gases might wander for millennia without ever meeting. By providing a physical surface for them to gather on, the dust grain dramatically increases the local concentration of reactive elements. Allow your hands to rest completely still, feeling the cool, steady surface beneath your fingertips, grounding you as we explore these microscopic frozen worlds. This quiet accumulation of diverse ices sets the stage for chemical reactions that would be mathematically impossible in a purely gaseous environment, evolving the simple ash into a densely packed multi-layered chemical reactor. Cosmic rays occasionally pierce the dark, protective boundaries of the molecular clouds, acting as invisible triggers that gently warm the ice and spark entirely new reactions. These high-energy particles, accelerated to near-light speed by distant supernovae, streak through the frozen nurseries like microscopic lightning bolts. When one of these energetic projectiles strikes an icy mantle, it shatters the frozen bonds of the trapped water, ammonia, and carbon monoxide molecules. Deep within the fractured ice, this sudden injection of energy creates highly reactive molecular fragments known as radicals, which immediately seek out new partners to stabilize themselves. As the tiny localized area briefly warms and then rapidly refreezes, these radicals recombine into much more complex heavy organic molecules like methanol and formaldehyde. It is a beautiful irony that the most violent, penetrating radiation in the universe is responsible for driving the delicate chemistry of creation. Notice how this continuous, subtle bombardment slowly changes the composition of the mantle over millions of years. What began as a simple mixture of frozen gases is gradually baked into a rich, organic sludge, heavily laden with carbon-based compounds. The icy pearl slowly darkens and yellows, wearing the chemical scars of its long exposure to the ambient energy of the galaxy. These icy coatings act as formidable protective blankets, effectively shielding the fragile new molecular bonds from the harsh, degrading ultraviolet radiation of nearby stars. While cosmic rays provide the internal spark, ambient starlight threatens to permanently destroy any complex molecules by blasting them back into basic atoms. However, the thick outer layers of the amorphous ice mantle absorb and diffuse this incoming light, acting like a microscopic ozone layer for the delicate organics forming deeper inside. If we were to look closer at the surface of the grain, we would see the outermost molecules constantly being broken apart and reforming, sacrificing themselves to protect the interior. This dynamic, sacrificial crust ensures that the heart of the chemical reactor remains stable and secure even as the particle drifts near the glowing edges of the cloud. The water ice in particular is incredibly efficient at soaking up the specific wavelengths of light that are most dangerous to carbon bonds. Take a slow, deep breath in, feeling the air fill your lungs, and let it out smoothly, embracing the secure, protective warmth of your own environment. Without this simple, frozen shield, the intricate organic chemistry required for life would be sterilized from the cosmos before it ever had a chance to fully develop. Deep within these frigid, silent nurseries, the actual building blocks of life are quietly assembled directly on the surface of floating dust. Protected by the sacrificial outer layers and energized by passing cosmic rays, the simple organic sludge continues to evolve, chaining carbon atoms together into increasingly elaborate structures. Sugars, lipid precursors, and even basic amino acids are forged within this microscopic frozen crucible. Surprisingly, these profound chemical milestones do not occur in the warm, churning oceans of a habitable planet, but in the absolute freezing desolation of interstellar space. The dust grain provides the essential scaffold, holding the reactants in place while the slow, patient forces of the cosmos do their invisible work. It is a mesmerizing realization that the fundamental architecture of biology is predestined by the physics of cold, floating ash. Picture the immense patience of this process, completely hidden from optical telescopes, yet laying the groundwork for everything we consider alive. By the time a planetary system actually begins to form, the local dust is already heavily laden with the complex organic cargo needed to eventually seed a biosphere. We are discovering that life's earliest chemical prologue is written in frost on the surface of wandering stones. When a young star finally ignites nearby, its gentle, expanding warmth causes these carefully constructed icy mantles to gracefully sublime back into gas. The birth of a new sun sends a wave of thermal energy rippling through the dark molecular cloud, slowly raising the temperature of the surrounding environment above the crucial freezing point of the volatiles. The solid ice does not melt into a liquid, but instead transitions directly from a solid frost into a vibrant, expanding halo of vapor. This cosmic thaw liberates millions of years' worth of trapped complex molecules, suddenly releasing them into the surrounding gaseous nebula. The protective shell evaporates, leaving behind the original ancient grain of stellar ash, now stripped bare and ready to be incorporated into a new planetary disk. It is a grand unveiling, where the hidden chemical treasures forged in the dark are finally released into the light. If we were to observe this transition with radio telescopes, we would see the previously dark, silent region of space suddenly light up with the distinct chemical signatures of heavy organics. The newly ignited protostar is briefly surrounded by a fragrant, rich mist of evaporated alcohol, water, and simple sugars. The icy pearl sacrifices itself, enriching the stellar nursery with the vital ingredients of creation. Picture the intricate, delicate dance of single hydrogen atoms finding each other on the jagged surface of a dust grain to form the molecular hydrogen that literally fuels the cosmos. Hydrogen is the most abundant element in the universe, but in the near-perfect vacuum of space, two lone hydrogen atoms almost never collide and stick together on their own. They require a physical meeting place, a microscopic tavern where they can briefly linger, connect, and bond into a stable molecule. The porous, icy surface of the mantle provides the perfect trap. A wandering hydrogen atom lands on the frost and nervously skitters across the surface until it encounters another. Once they meet, they instantly lock together, and the energy released by their union kicks the newly formed pair right back off the grain and into the surrounding cloud. This silent, continuous process is the primary engine generating the vast oceans of molecular gas that eventually collapse to form new stars. Let your facial muscles relax entirely, releasing any tension in your jaw, mirroring the effortless, natural connections happening endlessly in the dark above. The simple existence of these frosted specks is the vital bottleneck that controls the rate at which the entire galaxy can produce new suns. The silent, patient chemistry happening on these frosted specks is directly responsible for the incredibly rich variety of gases observed in active star-forming regions. Before astronomers fully understood the role of dust, the sudden appearance of heavy, complex gases around newborn stars was a perplexing mystery. Gas phase chemistry alone, occurring in empty space, is far too slow and inefficient to account for the sudden, vibrant blooming of organic molecules. Deep within the Orion Nebula and other stellar nurseries, the invisible fingerprint of the dust is revealed by the specific ratios of the evaporated gases. The unique combinations of methanol, ammonia, and water vapor match perfectly with the theoretical yields of an icy mantle reactor, proving that the gas was previously solid. The vibrant chemical diversity of the universe is not a product of the void, but of the surface. Notice how this profound realization shifts our understanding of the interstellar medium from a barren emptiness to a highly active, interconnected ecosystem. The dust grains act as tiny, industrious factories, laboring in the dark to assemble the complex molecules that the gas phase alone could never achieve. When the ice finally thaws, it transforms a simple hydrogen cloud into a rich, fertile chemical oasis. Without this simple, incredibly pervasive icy catalyst, the universe would completely lack the complex chemistry necessary to eventually form life as we know it. The gap between the chaotic, fiery birth of elements in a dying star and the organized, delicate biology of a living cell is impossibly vast. The frozen mantles on microscopic grains of ash provide the only known bridge across that divide, serving as the quiet, patient mediators of cosmic evolution. Surprisingly, the frost crystallizing on a silent winter windowpane on Earth is operating on the exact same physical principles that assemble the precursors of our own DNA. The water that makes up our oceans, and the carbon that builds our cells, both required a long, frozen hibernation in deep space to find each other. The dust grain is not merely a piece of debris, but the fundamental substrate upon which the possibility of existence is written. If we were to look closer at the grand narrative of the cosmos, the dark, obscuring clouds are not barriers to our understanding, but the very wombs of complexity. The icy mantles demonstrate that the universe is inherently biased toward creating structure, using the coldest, darkest places to quietly prepare for the light. It is an exquisite, perfect system where nothing is wasted, and even the smallest, coldest speck of ash is vital to the whole. The exquisite sense of being vital to the whole is most clearly revealed as we watch how these tiny particles interact with the invisible magnetic framework of the galaxy. Floating through the galactic magnetic field, spinning dust grains do not tumble aimlessly, but naturally align their long axes perpendicular to the magnetic lines of force. They respond to a grand, silent influence that threads through the Milky Way like invisible harp strings, connecting the smallest specks to the larger structures. This alignment is a slow, hypnotic process that occurs across the vast, empty chasms of the interstellar medium. Even in the most isolated regions, the magnetic field exerts a gentle but persistent pull, coaxing each grain into its proper place in the cosmic order. It is a testament to the interconnectedness of all things, where the orientation of a microscopic flake of ash is dictated by the massive currents of the entire galaxy. Notice how this orderly arrangement transforms the chaotic void into a structured environment where every particle plays its part. The grains are not just debris, but active participants in an electromagnetic symphony that spans thousands of light years. They serve as the visible indicators of a force that remains otherwise hidden from our eyes, revealing the grand architecture of the night sky. This invisible choreography of aligned grains causes the starlight passing through the clouds to become gently polarized, filtering the radiance of distant suns. As the light waves encounter the oriented particles, they are subtly constrained, with the dust absorbing or scattering photons based on their specific wave direction. What was once a chaotic, multi-directional glare becomes an ordered, rhythmic pulse as it journeys toward our waiting eyes. Imagine the light from a far-off cluster of stars traveling for thousands of years only to be refined by this pervasive, shimmering veil. The polarization serves as a celestial signature, a quiet record of every magnetic encounter the light has experienced on its long trip through the dark. It is a beautiful, subtle transformation that softens the raw power of the stars into a more nuanced and textured luminescence. This process provides a unique window into the hidden properties of the interstellar clouds, allowing us to see what was previously invisible. By measuring the degree of polarization, we can determine the density and orientation of the dust that hides the heart of the galaxy. It is a masterpiece of natural filtration, turning the immense void into a sophisticated optical instrument. Deep within the observation rooms of great telescopes, astronomers watch this polarized light to trace the delicate, sweeping curves of magnetic fields across entire galaxies. By mapping the direction and strength of the polarization, they can visualize the invisible currents that flow through the spiral arms of the Milky Way. This technique reveals a grand, hidden architecture that governs the flow of gas and the eventual formation of new stars. As you rest here, notice the gentle, rhythmic rise and fall of your chest, a steady internal motion that connects you to the quiet patterns of the natural world. This mapping allows us to see the galaxy as a living, breathing entity, shaped by forces that are as pervasive as they are unseen. The curves and eddies of the magnetic fields act as the skeletal structure of the cosmos, providing a framework for the gas and dust to gather. If we were to look closer at these maps, we would find that the magnetic field lines often follow the majestic spiral patterns of the stars themselves. The dust acts as a loyal messenger, translating the silent language of electromagnetism into a visual masterpiece of light and shadow. It is a profound realization that the same forces that align a simple compass needle on Earth are responsible for organizing the matter of an entire galaxy. Imagine trillions of microscopic compass needles, all silently turning in unison as they drift through the velvet darkness of our home galaxy. Though each grain is separated from its neighbour by vast distances, they all share a common orientation, synchronized by the pervasive magnetic field of the galactic disk. It is a massive collective performance where every tiny bit of matter acts as a sensitive sensor for the invisible forces of the cosmos. Surprisingly, the universe maintains this order across millions of light years, ensuring that the ballet of the grains remains consistent and unbroken. These tiny compasses do not point toward a single northern pole, but instead curve and swirl in harmony with the local magnetic environment. They provide a high-resolution view of the invisible stresses and tensions that exist within the interstellar medium. This collective alignment is one of the most widespread phenomena in the universe, occurring in almost every corner of the galactic plane. It suggests a level of organization that defies the seemingly random nature of the void. Each grain is a tiny participant in a grand magnetic conspiracy that helps to maintain the stability and structure of the starry realms above. The precise mechanism of this alignment involves the subtle interaction of starlight pushing against the irregular shapes of the grains, a process known as radiative torque. Because the dust specks are jagged and asymmetrical, the pressure of incoming light pushes unevenly against their various surfaces, much like a breeze catching a windmill. This subtle, constant pressure forces the grains to spin with incredible speed and eventually align themselves with the local magnetic field. Take a moment to feel the complete stillness of your limbs, allowing any lingering tension to dissolve into the surface beneath you. This constant interaction between light and matter ensures that the grains never stop their spinning dance, even in the coldest reaches of space. The starlight itself acts as the engine, providing the energy necessary to maintain the magnetic orientation of the entire interstellar cloud. If we were to look closer at a single grain, we would see it acting as a tiny light-driven motor, converting the energy of photons into rotational motion. This elegant solution to the problem of alignment demonstrates how the universe uses its most abundant resource, light, to organize its most diffuse material. It is a harmonious exchange where the radiance of the stars brings order to the wandering ash. These aligned particles act like a massive galaxy-spanning cosmic polarizing filter, subtly altering the glow of every star that lies behind them. For an observer on Earth, the dust serves as a protective lens, softening the harsh intensity of distant stellar nurseries and revealing the subtle textures of the interstellar medium. This filtration is not a static barrier, but a dynamic, evolving layer that changes as the magnetic fields shift and flow over eons. Surprisingly, this galactic filter is so effective that it can completely hide certain types of radiation, forcing us to use specialized instruments to see the full picture. The dust selectively removes specific orientations of light, leaving behind a polarized glow that carries information about the entire path the light has traveled. It is a natural encryption system, where the story of the galaxy is encoded in the vibration of its light. Notice how this filter adds a layer of depth and complexity to the night sky, turning a simple view of stars into a multi-dimensional map. The dust is not just obscuring our vision, it is enriching it with data that would otherwise be lost. By understanding the properties of this cosmic lens, we can look through the veil and see the true, unvarnished beauty of the universe. Even the faint afterglow of the Big Bang itself is filtered and twisted by this pervasive, shimmering veil of magnetized dust. As the ancient light of the cosmic microwave background travels across billions of years to reach our senses, it must eventually pass through the local dust of our own galaxy. This interaction leaves a distinct polarized signature that acts as a foreground contamination, masking the true signal of the universe's birth. Deep within the data from space telescopes, scientists work tirelessly to peel back this dusty layer and reveal the pristine dawn of time. The magnetized grains in the Milky Way act as a final, local hurdle, twisting the 13-billion-year-old light just before it reaches our detectors. It is a humbling reminder that our own galactic neighborhood can influence our understanding of the entire cosmos. Take a slow, deep breath in, feeling the air fill your lungs, and let it out smoothly, embracing the secure, protective warmth of your own environment. This interaction between the local dust and the ancient background light links the beginning of time to the present-day state of our galaxy. The dust serves as a bridge between the primordial past and the structured, magnetic present we inhabit today. Radiative torques from nearby stars gently spin the grains up to billions of rotations per second, turning them into incredibly stable, tiny gyroscopes. This relentless bombardment of photons acts as a constant push, accelerating the microscopic specks to speeds that would tear larger objects apart. The resulting gyroscopic stability is what allows the grains to maintain their precise alignment against the random buffeting of passing gas molecules. If we were to look closer at these spinning dervishes, we would find them to be remarkably resilient, using their own motion to resist any force that would knock them out of position. They are among the fastest rotating objects in the known universe, humming with a kinetic energy that remains invisible to the naked eye. This rapid rotation is the key to the entire magnetic ballet, providing the physical foundation for the polarization of starlight. This hidden energy permeating the dark clouds adds a sense of vibrancy to what might otherwise seem like a cold, static environment. The interstellar medium is not just a collection of drifting ash, but a field of trillions of high-speed gyroscopes, all perfectly synchronized with the magnetic heartbeat of the galaxy. It is a high-energy performance happening in total silence, hidden within the folds of the nebula. Notice how the largest, fluffiest grains are the most easily aligned by the galactic fields, acting as the most sensitive magnetic probes in the universe. Their increased surface area allows them to catch more starlight, generating stronger torques that snap them into position with remarkable efficiency. These complex, porous structures become the primary telltales of the magnetic environment, vibrating with information about the forces shaping their home. Surprisingly, these fluffy grains are often composed of smaller particles that have stuck together, creating a jagged, irregular shape that is particularly responsive to light pressure. They are the giants of the microscopic world, leading the dance and setting the orientation for the smaller, more stubborn particles around them. Their sensitivity allows astronomers to detect even the weakest magnetic fluctuations in the deepest reaches of space. This variability in the dust population means that different parts of the galactic magnetic field are mapped by different types of grains. The largest particles provide the broad strokes of the magnetic map, while the smaller ones fill in the finer details. It is a tiered system of sensing that ensures no part of the galaxy's invisible structure remains completely hidden from our view. The slow, majestic dance of these aligned particles maps the invisible forces that help shape the grand structure of our entire galaxy. By following the collective orientation of the dust, we can see how magnetic fields channel the flow of matter, preventing some clouds from collapsing while guiding others towards stellar birth. It is a silent electromagnetic symphony that links the smallest grains of ash to the epic evolution of the Milky Way. Deep within the spiral arms, these magnetic fields act as invisible scaffolding, providing the support necessary to maintain the shape and stability of the galactic disk. The dust grains are the only visible manifestation of this support system, allowing us to witness the structural integrity of our cosmic home. Without these fields, the galaxy would be a much more chaotic and disorganized place, lacking the graceful curves we see today. Take one last moment to appreciate the incredible scale of this magnetic ballet, where trillions of tiny particles work together to reveal the hidden soul of the universe. Every grain is a small but vital thread in a grand electromagnetic tapestry that covers the entire sky. As we look at the stars, we're also seeing the invisible lines of force that hold everything in its proper, peaceful place. Within those peaceful places where the magnetic tapestry is most densely woven, a heavy, hushed stillness begins to settle over the dark molecular clouds, mirroring the tension of the air just before a gentle summer rain. This prenatal silence is the true precursor to all creation, a moment where the random, chaotic vibrations of the void finally give way to the singular, inward pull of gravity. Deep within the densest, darkest pockets of these interstellar clouds, the scattered grains of ash and ice are no longer content to drift aimlessly through the vacuum of the spiral arms. Instead, they begin to draw closer to one another in a slow-motion huddle, a collective movement that signals the end of their long, lonely migration. This initial gathering is subtle, a silent conversation between particles that have spent eons apart, but now feel the undeniable weight of their shared destiny as the pressure of the surrounding gas begins to mount. The vast, empty distances that once defined their existence are slowly closing, creating a region of space that feels thick with anticipation and heavy with the promise of what is to come. It is in these lightless, quiet chasms that the universe begins to fold in on itself, preparing the ground for the most spectacular transformation in the cosmos. As the collapse accelerates and matter begins to fall toward a common center, the potential energy of the falling gas and dust is converted into a dangerous rising heat that threatens to tear the fledgling core apart. In a typical cloud composed of pure hydrogen gas, this thermal pressure would quickly expand the material back outward, effectively halting the birth of the star and leaving only a diffuse, cooling mist of unfulfilled potential. Surprisingly, the universe has provided a built-in cosmic thermostat in the form of the very dust that permeates these dark regions, acting as a crucial regulator for the eventual birth of light. This microscopic grit, composed of the ancient carbon, soot and silicates we have followed, absorbs the frantic kinetic energy of the colliding gas molecules as they crash into the center. By taking this heat into its own structure, the dust prevents the internal temperature of the collapsing pocket from spiraling out of control, maintaining the delicate balance required for gravity to continue its work. It is a quiet, industrious intervention, a mechanical necessity that allows the cloud to pack itself tighter and tighter without succumbing to its own internal pressure. Without this thermal anchor, the brilliant stars we see tonight would have remained as nothing more than scattered atoms lost forever across the empty dark. By radiating this captured heat away as soft, invisible infrared light, the dust allows the dense core to remain incredibly cool and continue its gentle inward collapse through the darkness. The grains act as tiny, efficient radiators, broadcasting the excess energy out into the surrounding void where it cannot interfere with the gravitational work occurring at the heart of the cloud. This continuous thermal release is the heartbeat of the stellar nursery, a steady pulsing of energy that allows matter to pack closer and closer together in a state of tranquil compression. If we were to look closer at the invisible spectrum using our most sensitive instruments, we would see these dark, imposing clouds glowing with a tranquil, warm luminescence that defies their outward appearance. This infrared glow is the only outward sign of the titanic forces at play within the shadow, a soft whisper of heat that carries the story of the star's assembly to any distant observer. The dust effectively cleanses the core of the friction of its own birth, ensuring that the environment remains stable enough for the long, arduous process of contraction to reach its conclusion. It is a masterful display of cosmic engineering, where the smallest particles of solid matter manage the immense energy of a future sun. Deep within these shadowy cocoons, newborn stars are entirely hidden from the prying eyes of optical telescopes, sequestered away in a private sanctuary of their own making during their most vulnerable stage. The surrounding envelope of dust is so thick and so perfectly opaque that it swallows every single photon of visible light emitted by the labouring protostar at the centre of the globule. To an outside observer, the region appears as a perfect, terrifying void, a black hole in the fabric of the starry sky that seems to defy the very existence of light. This darkness is not an absence of life, however, but a veil of protection, ensuring the delicate processes of gravitational heating can continue in total isolation, from the harsh radiation of the external galaxy. Within this cradle of soot and ice, the protostar grows in size and power, its presence betrayed only by the subtle, warm infrared signature that leaks through the dusty walls and out into the void. It is a time of profound mystery and hidden growth, a stage of development where the future sun is nurtured by the very shadows that hide it from the rest of the universe. We are left to imagine the brilliance forming within, a secret light that will one day redefine the landscape of the local heavens once the veil is finally lifted. Take a slow, deliberate breath, and as you exhale, notice the complete stillness of your hands and the steady support of the surface beneath your resting body. Picture the dust particles colliding and sticking together in the increasingly crowded centre of the collapsing cloud, their jagged edges interlocking like microscopic puzzle pieces in the dark. As the density of the core increases, the frequency of these encounters rises dramatically, leading to the rapid growth of the grains into larger, more complex structures through the force of simple friction. What began as individual, isolated specks of soot and silicate now coalesce into pebble-sized clumps, the first solid foundations of a future solar system and all the worlds that may one day orbit it. This relentless gathering is a messy, beautiful process of aggregation, where the random debris of the galaxy is forged into something far more substantial than the sum of its parts. These growing pebbles act as gravitational magnets, drawing even more material toward them as they swirl in the tightening vortex of the newborn star's influence. It is the beginning of the end for the dust's life as an interstellar wanderer, as it starts the transition toward becoming the literal ground and mineral wealth of a new world. These dense nurseries, known as Bok globules, look like ink drops spilled across the glowing backdrop of brighter, more distant nebulae, creating a striking contrast in the cosmic landscape of our galaxy. They are the most compact and isolated star-forming regions known to astronomers, appearing as stark, velvet black silhouettes that seem to float independently against the radiant gas of the spiral arms. When viewed through a powerful lens, their edges appear soft and fuzzy, a region where the dust is slightly less concentrated and allows a faint glimmer of background starlight to leak through. This visual effect gives them a three-dimensional quality, as if they were solid, dark stones suspended in a river of light, waiting for the currents to wash them away. Inside these ink drops, the pressure is building toward a breaking point, and the gravity is so intense that nothing, not even the fierce winds of the galaxy, can disrupt the internal collapse. They are the ultimate triumph of mass over the expansive forces of the interstellar medium, a final huddle of matter before the spark of ignition. Each globule is a promise of a future system, a dark seed planted in the fertile garden of the nebula, waiting patiently for its season to begin. The surrounding dust gracefully channels the newborn star's powerful outflows into stunning, narrow jets of glowing material that pierce through the surrounding darkness like cosmic searchlights across the void. As the protostar begins to spin and gather mass from the surrounding cloud, it generates fierce, chaotic winds that would normally blast outward in every direction, potentially disrupting the delicate accretion process. However, the thick, dusty disk that has formed around the equator of the star acts as a cosmic funnel, restricting these winds and forcing them into two symmetrical, high-velocity beams at the poles. These jets serve as the first visible cry of a waking sun, announcing its presence to the galaxy, even while it remains hidden deep within its opaque protective cocoon. They travel for trillions of miles through the interstellar medium, slamming into the surrounding cloud and creating glowing knots of gas known as Herbig-Haro objects. This interaction highlights the dual nature of the dust, which both contains the star's energy and provides the precise structure through which that energy can finally escape. It is a spectacular display of celestial dynamics, where the very material that traps the light also creates its most dramatic and focused path outward. Without the cooling presence of this simple, pervasive soot, the universe would struggle to form low-mass stars like our own sun, leaving the galaxy populated only by short-lived violent giants. The specific chemical composition of the dust, those silicates and carbon grains we have tracked, provides the exact thermal properties required to create smaller, stable stars that can burn for billions of years. These stars are essential for the long-term stability of the universe, as they provide the steady, gentle heat necessary for life to evolve on surrounding planets over geologic timescales. Dust allows the gas within a molecular cloud to fragment into smaller, more manageable pieces, preventing the entire mass from collapsing into a single, massive, and unstable entity. This fragmentation is the key to stellar diversity, ensuring that the galaxy is filled with a variety of stars of all sizes and temperatures, rather than just a few brilliant monsters. Our own Sun is a direct beneficiary of this dusty heritage, a star that exists only because the ancient ash of its predecessors kept the nursery cool enough for it to form. We are the inhabitants of a system that was carefully regulated by microscopic grit, a humbling thought that connects our daily lives to the thermal physics of the void. Surprisingly, the very material that obscures the birth of stars from our view is the exact same material that makes their birth physically possible in the first place within the galactic disk. As you rest in this quiet moment, feel the steady, rhythmic pulse of your own heart, a constant reminder of the life that is forged in the shadows of the cosmos. This realization brings us to a profound cosmic paradox. The opacity that creates the darkness is also the essential mechanism that provides the cooling necessary for the light to ignite. If the molecular clouds were perfectly transparent to all forms of energy, they would be unable to shed the heat of their own collapse, and the gas would remain too hot and too active to ever coalesce. The dust acts as both a shield and a bridge, protecting the nascent sun from external radiation, while simultaneously acting as the conduit for its internal energy released to the vacuum. We owe our ability to see the stars to the very substance that briefly blinds us to their creation, a reminder that in the grand design of the cosmos, the most essential truths often hide within the deepest shadows. This paradox defines the relationship between matter and light, suggesting that the most brilliant beginnings require a period of total, unyielding darkness. As the central protostar finally ignites its nuclear furnace and begins to shine with the fierce, independent power of fusion, its brilliant light begins to slowly push the remaining envelope of dust away. The pressure of the newly born stellar photons acts like a gentle but relentless broom, sweeping the nursery clean of the soot and ice that once provided its protection and thermal stability. This final act of clearing marks the transition from a dark, collapsing cloud to a bright, independent sun, standing alone in the quiet, empty chasm of the galaxy. The dusty envelope, having fulfilled its role as a thermostat, a shield, and a channel for the star's energy, is dispersed back into the interstellar medium to begin the cycle of renewal anew. What remains is a shining star, often surrounded by a thinning disk of leftover grit that will eventually go on to form the planets, moons, and perhaps, one day, sentient beings. The heavy, hushed stillness of the collapse is replaced by the vibrant, energetic pulse of a living sun, and the veil is finally lifted to reveal the latest addition to the tapestry of the night sky. The journey from ash to light is complete, leaving behind a cleared path for the future evolution of the new solar system and all its potential life. The journey from ash to light reaches its most graceful conclusion as the leftover dust settles into a flat, spinning disk around the newborn star. As the central sun ignites and begins to push away the outer envelope, the material that remains caught in its gravitational grip begins to flatten due to the conservation of angular momentum. This transition mirrors the hypnotic, swirling motion of cream slowly mixing into a dark cup of coffee, where the initial cloudiness gives way to structured, elegant spirals. The once chaotic cloud of grit and ice becomes an orderly plane, a thin sheet of cosmic matter extending billions of miles into the void. This spinning platform is the ultimate nursery for planetary bodies, providing a stable environment where gravity can exert its patient influence without the disruption of turbulent galactic winds. Every particle within this disk is now locked into a rhythmic orbit, following the same celestial path as its neighbours in a grand unified dance. The sheer flatness of this structure is a testament to the quiet power of physics, turning a three-dimensional mist into a two-dimensional blueprint for a future solar system. It is here, in this thin veil of rotating sand, that the first solid foundations of worlds are laid. Deep within this whirling mist, gentle collisions in the crowded disk cause the fluffy grains of silicate and carbon to stick together, building the first primitive meteoroids. In the vacuum of the disk, the surfaces of these particles are incredibly clean and reactive, allowing them to bind together through the subtle force of molecular stickiness. This process of accretion is slow and methodical, starting with microscopic aggregates that resemble delicate dust bunnies drifting through a lightless attic. These fragile clusters grow steadily as they encounter more material, gradually gaining the mass and structural integrity required to survive the increasingly frequent impacts of the inner disk. As these clusters grow from microns to centimeters, they begin to act as gravitational anchors, attracting even more debris from the surrounding environment. This phase of growth is a quiet, persistent accumulation, where the random debris of the nebula is woven into solid, cohesive objects. The fluffiness of the early grains is essential, as it allows them to absorb the energy of collisions without shattering, acting like cosmic shock absorbers. Over time, these soft aggregates densify into the rocky seeds of future asteroids and planetary cores. Notice how a phantom boundary of temperature, known as the snow line, dictates exactly where icy bodies like comets can form within this spinning theatre. Closer to the infant star, the intense heat vaporizes any water or volatile gases, leaving behind only the most resilient rocky and metallic grains to build the inner planets. Beyond this invisible threshold, the environment remains cold enough for water, ammonia, and methane to stay frozen, coating every grain of dust in a thick crystalline shell of ice. This stark thermal divide creates two distinct realms within the disk, separating the small, rocky inner worlds from the massive, gas-rich giants of the outer system. As you lie still, feeling the gentle rhythm of your heart, let the quiet weight of the world around you serve as a reminder of the steady forces that once gathered this dust into the ground beneath you. The snowline acts as a cosmic sorting machine, ensuring that the chemistry of each planet is perfectly tuned to its distance from the sun. In the outer reaches, the abundance of frozen ices allows protoplanets to grow rapidly, eventually becoming massive enough to capture vast envelopes of hydrogen and helium gas. This thermal architecture is the reason our own solar system possesses such a diverse and orderly arrangement of worlds. This cosmic architecture has been captured in breathtaking detail by our most powerful modern telescopes, revealing beautiful swirling rings and dark, prominent gaps. These high-resolution images show us the footprints of infant planets that are actively sweeping up the dust and gas along their orbital paths. As a young world grows, its gravity clears a wide lane through the disk, leaving behind a void that appears as a dark, circular break in the glowing rings of material. These observations provide a direct window into the violent yet orderly process of planetary birth, showing us that the formation of a solar system is a dynamic and visible event. The gaps are not empty voids, but are the sites of intense gravitational work, where the raw materials of the disk are being consolidated into a single massive body. The remaining rings of dust continue to glow with the reflected light of the central star, mapping out the regions where new worlds have yet to emerge. It is a stunning visual confirmation of our theories, proving that the silent, dusty disks we imagined for centuries are a universal reality. These images allow us to witness the exact moment a planetary system transitions from a hazy cloud to a structured family of worlds. Over millions of years, this relentless gathering of cosmic sand transforms a hazy, disorganized disk into a structured and orderly solar system. The chaotic orbits of the early grains are gradually synchronized by gravity, weeding out the unstable paths and concentrating the mass into a few dominant bodies. This transition from a diffuse mist to a series of solid spheres is one of the most profound reorganizations of matter in the universe, turning a cloud of ash into a gallery of planets. The clockwork precision of our own planetary motions is the final result of this long, dusty struggle for dominance within the disk. As the disk thins, the light of the young star can finally travel unimpeded, illuminating the newly formed worlds and clearing away the last remnants of the original nebula. The vast majority of the dust is either incorporated into the planets or blown out into interstellar space by the intensifying stellar wind. What remains is a clean, stable system where the planets move through a near-perfect vacuum, their origins hidden in the solid rock beneath their surfaces. This transformation marks the maturity of the solar system, where the era of dust gives way to the era of geology and, eventually, biology. Imagine the silent, slow-motion cascade of dust falling onto the surface of a growing protoplanet, slowly building a new world through the patient accumulation of microscopic layers. As the young planet sweeps through its orbit, its gravitational field acts like a giant vacuum, drawing in millions of tons of silicate grit and metallic flakes every single day. This constant rain of material adds mass and energy to the body, heating the interior and allowing the planet to differentiate into a core, mantle, and crust. The process is a grand, celestial construction project where the building blocks are no larger than a speck of soot. Each layer of dust brings with it the unique chemical history of the region where it formed, contributing to the complex mineralogy of the growing world. This accretion is not a violent bombardment, but a steady, persistent flow of matter that gradually smooths out the surface and builds the bulk of the planet. This silent fall of these grains is the heartbeat of the world building, a quiet accumulation that occurs over spans of time that defy human comprehension. Eventually, the planet reaches its final size, a solid testament to the power of trillions of tiny particles working in unison. Surprisingly, the process of assembly is occasionally punctuated by intense bursts of heat. As frictional heating within the inner disk flash melts, dust clumps into small glass-like spheres called chondrules. These molten droplets cool rapidly in the vacuum, solidifying into tiny bead-like inclusions that are found today inside the most ancient and primitive meteorites. Chondrules are the seeds of the rocky planets, representing a phase where the cold dust was briefly transformed by the chaotic energy of the early solar system. Their presence tells us that the protoplanetary disk was a place of extreme transitions, where matter was constantly being melted, forged, and recycled. Take a moment to appreciate the absolute stillness of your own hands, grounded and safe while the ancient fires of the cosmos continue to cool into the solid reality we inhabit. These glassy spheres act as chronological markers, allowing scientists to date the very first moments of our solar system's birth with incredible precision. They are the primary components of the material that first clumped together to form the Earth, providing the rocky grit that eventually became our bedrock. Every chondrule is a tiny capsule of history, preserving the memory of a time when our world was nothing more than a swirling cloud of molten droplets and cooling sand. The vast diversity of planets found throughout our galaxy all trace their origins back to the subtle and varied chemistry of these original dusty disks. The relative abundance of iron, water, and carbon within the local nebula determines whether a system will produce scorched iron worlds, lush water giants, or dark carbon-rich spheres. Every disk is a unique recipe book, blending the elements forged in previous generations of stars into a new and distinct planetary architecture. This chemical inheritance ensures that no two solar systems are exactly alike, creating a galaxy filled with an endless variety of environments and possibilities. Notice how the specific minerals present in the dust dictate the eventual geological activity and atmospheric composition of the resulting planets. A disk rich in radioactive isotopes will produce worlds with hot, churning interiors and active volcanoes, while a disk dominated by ice will lead to quiet, frozen moons. This fundamental link between the microscopic grain and the planetary scale is the key to understanding the sheer variety of worlds we observe. The dusty disk is the source of all planetary character, defining the fate of a world long before it has even finished forming. If we were to look closer at the outermost edges of a forming system, we would find that comets act as pristine, frozen time capsules, preserving the exact dust and ice mixtures of the original protoplanetary nebula. Because they formed far from the heat of the young star and have remained in the deep freeze of the outer system for billions of years, comets have never been melted or geologically altered. They are the unopened mail of the early solar system, containing the original raw ingredients that were present before the planets were built. Analysing the dust within a comet is like reaching back through time to touch the very mist from which we were made. This ancient material is rich in complex organic molecules and volatile gases that have been lost from the inner planets over the eons. Comets serve as the memory of the disk, holding on to the fragile chemical signatures that the sun's heat destroyed elsewhere. When a comet occasionally wanders into the inner solar system and releases its dust, it provides us with a direct sample of our own prenatal environment. They are the messengers of the deep past, reminding us of the cold, icy origins of the vibrant worlds we see today. Every mountain, ocean, and continent on Earth was once just a diffuse cloud of microscopic grains orbiting a young, flickering sun. The granite peaks that pierce our atmosphere and the deep basalt floors of our seas are the direct descendants of the silicate flakes forged in the breaths of dying stars billions of years ago. We walk upon the gathered ash of the ancient universe, a planet built from the patient accumulation of invisible specks that refuse to be scattered by the solar wind. This realization bridges the gap between the infinite scale of the cosmos and the intimate reality of our daily lives. The very silicon in our technology and the iron in our bedrock began as wandering dervishes in a protoplanetary disk, dancing through the dark before falling into the gravitational embrace of our nascent world. Every grain of sand on a modern beach is a small, weathered fragment of a story that began in the heart of a nebula. We are the inhabitants of a massive, consolidated cloud of cosmic dust, living out our lives on a stage built from the most humble and ancient materials of the heavens. As we look at the solid ground beneath our feet, we're really looking at the final, quiet, resting place of the stars. Though we stand upon the solid, quiet resting place of the stars, the space between our worlds remains far from empty. Surprisingly, our solar system is still filled with a faint, pervasive haze of dust that drifts like a ghostly mist across the orbits of the planets. This thin veil is not a stagnant relic of the past, but a living feature of our neighbourhood, continually replenished by the gentle crumbling of icy comets and the slow, grinding collisions of rocky asteroids. It is a persistent reminder that the processes of creation and fragmentation are still very much alive today. This cosmic mist is most concentrated along the ecliptic plane, where the majority of planetary and asteroidal motion occurs. As these bodies travel through their orbits, they shed microscopic fragments that are caught in the sun's gravitational influence, creating a diffuse cloud that permeates the inner system. Even after billions of years of planetary sweeping, the void remains subtly occupied by this ancient drifting grit. This vast cloud of interplanetary grit interacts with the sun's radiance to produce one of the most ethereal sights in the night sky. Known as the Zodiacal Light, it manifests as a ghostly, towering pyramid of soft illumination, stretching upward from the horizon just after the sun has set or before it rises. It is the collective reflection of billions of microscopic grains, each catching a tiny fraction of starlight and scattering it back toward our world. This celestial glow traces the very plane of our solar system, mapping out the flattened disk where the dust is most concentrated. To see it requires a truly dark sky, free from the glare of cities, where the faint luminescence of the dust can compete with the brilliance of the stars. It serves as a visual bridge between our world and the sun, a glowing path of sand that marks the highway of the planets. If we were to look closer at this pyramid of light, we would realise we are looking at the very material that once formed the protoplanetary disk, now thinned and scattered by the passage of eons. The light is soft and tranquil, a hushed reminder of the sheer volume of matter that still wanders the spaces between the familiar planets. It is the signature of a system that is still evolving and shedding its skin. Every single day, a silent and invisible rain of dozens of tons of cosmic dust gently drifts down through Earth's atmosphere to settle on our oceans, forests, and rooftops. These microscopic wanderers have travelled across the vast cold reaches of the solar system, only to finally find a home here among us. This relentless influx of material is a quiet, ongoing connection between our planet and the deeper reaches of the cosmic void. As you rest in this quiet moment, feel the absolute stillness of your own breath, knowing that even now the sky above is softly showering the world with the ancient debris of the heavens. Most of these particles are so small that they do not burn up as meteors, but instead decelerate gently in the upper atmosphere, floating downward like microscopic snowflakes. They settle into the soil and the sea, becoming an inseparable part of the very ground we walk upon. Deep within the layers of Arctic ice and the depths of the Pacific, scientists find these extraterrestrial messengers preserved for thousands of years. They provide a continuous record of the solar system's activity, a dusty diary of cometary passages and asteroid breakups. Our world is constantly growing, accumulating the scattered remains of the wider universe one tiny grain at a time. If we were to look closer at the ordinary sediment in our rain gutters or the pristine, untouched snows of Antarctica, we could find perfectly spherical micrometeorites that have survived their fiery descent. These tiny, glass-like beads were once jagged grains of asteroid or comet debris that melted into droplets as they frictionally heated against our upper atmosphere. As they cooled during their long fall to the surface, they solidified into these beautiful, symmetrical shapes, preserving a record of their high-speed entry. They are the smallest travellers to reach our ground, hiding in plain sight as humble specks of sand that once drifted between the stars. When viewed under a microscope, their surfaces reveal intricate textures of iron and silicate, telling the story of their billion-year journey through the cold dark. They are tangible pieces of the cosmos that we can hold in our hands, remnants of the same material that built the rocky core of the Earth. Surprisingly, these micrometeorites represent the majority of extraterrestrial material that reaches our planet, far outweighing the larger rocks that occasionally strike the ground. They are the quiet majority of the heavens, a persistent drizzle of stardust that links the roof of your house to the heart of an asteroid belt. Their presence makes the concept of outer space feel intimate and immediate, right here in the palms of our hands. Picture the long, glowing tail of a comet as it sweeps through the inner solar system, a magnificent banner of dust pushed outward by the invisible pressure of sunlight. As the comet's icy heart warms near the sun, it releases millions of tiny particles that were trapped in frozen hibernation for billions of years. These grains are so light that the mere force of solar radiation is enough to accelerate them away from the sun, creating a shimmering trail that can stretch for millions of miles. It is a visual representation of the sun's power acting upon the smallest fragments of matter, a grand display of light and motion against the black velvet of the void. While the comet's gas tail glows with its own light, the dust tail shines simply by reflecting the brilliance of our star. This trail of debris is what the comet leaves behind as a legacy, a path of crumbs that will linger in orbit long after the comet itself has retreated to the outer dark. Notice how the tail always points away from the sun, regardless of the comet's direction of travel, steered by the relentless wind of light. This structure is a fragile, temporary monument to the comet's passage, a cloud of fine soot and ice that slowly diffuses and merges with the wider interplanetary medium. It is the process by which the frozen secrets of the outer system are shared with the inner realms. The spectacular displays of the Perseid and Leonid meteor showers are simply the result of the Earth gracefully ploughing through the dusty debris trails left behind by ancient comets. As our planet follows its steady orbit, it periodically intersects these concentrated rivers of cosmic sand, causing thousands of grains to incinerate in the upper atmosphere. Each brilliant streak of a falling star is the final, energetic moment of a single particle that may have spent eons drifting in the deep freeze of the outer solar system. As you allow your shoulders to drop and your muscles to loosen, imagine our planet as a silent ship moving through a sea of sparkling dust. This cyclical encounter is a rhythmic dance where our world sweeps up the discarded crumbs of passing icy wanderers, turning their destruction into a display of fleeting beauty. The meteors we see are the ghosts of comets, their solid remains finally meeting the warmth of a planetary atmosphere. Surprisingly, the timing of these showers is so precise because the dust trails remain remarkably stable in their orbits for centuries. We return to the same patches of debris year after year, a predictable meeting between the Earth and the ghosts of the deep past. It is a celestial appointment that allows us to witness the end of a dust grain's journey across the great expanse. Deep within the silence of orbit, our satellites and spacecraft are constantly bombarded by this microscopic grit, moving at speeds that make even the smallest grain a potential hazard. This relentless sandblasting requires engineers to design special shielding to protect sensitive instruments and pressurized modules from the impact of hypervelocity dust. A single particle, no larger than a speck of flour, carries the kinetic energy of a speeding bullet when it strikes a metal surface in the vacuum. Over time, the windows of space stations and the surfaces of solar panels become pitted with tiny craters, microscopic scars from an endless encounter with the solar system's debris. Notice how the quiet, seemingly empty space around our planet is actually a dynamic environment where our technology must learn to coexist with the ancient debris of the sun. The dust acts as a natural abrasive, slowly wearing down the artificial structures we place among the stars. This interaction reminds us that space is a physical place, filled with the tangible remains of the solar system's history. Even as we reach further into the void, we are walking through a mist of material that has been there for billions of years. Our journey through the stars is a journey through a field of microscopic diamonds and soot, each one a tiny obstacle or a piece of data to be understood. Surprisingly, the faint and delicate rings of Jupiter, Uranus, and Neptune are not composed of massive ice boulders like Saturn's, but are largely made of fine dust kicked up by meteor impacts on their small inner moons. Whenever a piece of interplanetary grit strikes a moon's surface at high speed, it ejects a cloud of debris that is too fast to fall back down, but too slow to escape the planet's gravity. This material spreads out into a thin, shimmering ring, caught in a permanent orbit around the giant planet. This process is a secondary use of the solar system's dust, where the destruction of a grain on a moon's surface creates a new structure of ethereal beauty. These rings are nearly invisible to the naked eye, revealing themselves only when backlit by the sun, like dust motes dancing in a beam of light. They are transient and fragile, constantly being replenished by new impacts and eroded by the planet's intense magnetic fields. If we were to look closer at these rings, we would see a record of the violence of the solar system, transformed into a display of perfect circular order. The moons act as the sources, and the planets act as the anchors. But it is the dust that provides the visible form. It is a delicate balance of motion and gravity, turning the debris of the void into a royal crown for the gas giants. Notice how the solar wind, a constant stream of charged particles from our sun, gently nudges the smallest dust grains outward, eventually sweeping them entirely out of the solar system and back into the interstellar void. For the tiniest particles, the outward push of light and particles overcomes the inward pull of gravity, launching them on a one-way trip toward the stars. This process ensures that the inner solar system is constantly being cleaned, even as new dust is being created by comets and asteroids. As you feel the weight of your body sinking deeper into a state of total relaxation, consider this grand, silent clearing of the cosmic neighbourhood. The sun acts as a master gardener, using its radiance to blow away the finest chaff and keep the planetary pathways clear. If we were to look closer at the boundaries of our system, we would see a faint outward-flowing mist of material returning to the grand galactic cycle. This outward migration connects our local system back to the wider galaxy, sharing our material with the spaces between the stars. The dust that once helped build our Earth is eventually returned to the void, perhaps to be caught up in the collapse of a new nebula millions of years from now. It is a slow, majestic exhale of matter, a quiet redistribution of the sun's gathered wealth. This local dust acts as a vital connecting bridge, constantly exchanging material between the different bodies of our planetary neighbourhood and weaving them into a single, interconnected system. A grain of dust from a Martian impact might eventually land on a moon of Saturn, or a fragment of a Kuiper Belt object might find its way into our own atmosphere. This slow-motion transfer of matter ensures that no world is a true island, but is instead part of a continuous swirling conversation of chemical and mineral elements. Every planet and moon is touched by this wandering mist, accumulating a thin layer of the wider solar system's history on its surface. The dust serves as a common denominator, a shared substance that links the scorched rocks of the inner system to the frozen giants of the outer dark. It is the connective tissue of our celestial home, a subtle web of matter that holds the story of every collision and every comet. As you remain in this state of peaceful stillness, imagine these microscopic messengers drifting endlessly through the dark, carrying the memory of one world to the surface of another. The solar system is a single, breathing entity, and the dust is the air that fills its lungs. In this grand exchange, we find the ultimate proof that every part of the cosmos is intimately related, bound together by a shared heritage of drifting ash and light. This shared heritage of drifting ash and light extends far beyond our local neighbourhood, where the dust acts as a cosmic mirror for the universe's most violent events. When a star suddenly erupts in a brilliant ephemeral flash, its light does not simply vanish into the void, but instead ripples outward and bounces off the surrounding dust clouds. This interaction creates a mesmerizing light echo, a visual ripple that moves across the nebula like a wave traveling across a still lake long after a stone has been dropped. The light travels through the interstellar medium at its fixed speed, illuminating different shells of material at different times and revealing the hidden three-dimensional structure of the clouds. This phenomenon allows us to see the same event from multiple angles and time delays, as the light takes longer paths to reach our eyes after reflecting off distant grains. It is a stunning display of celestial geometry, where the dust serves as a silent witness, capturing and replaying the history of a star's sudden outburst. If we were to look closer at these echoes, we would find that they act as a natural time machine, preserving the specific details of the initial explosion for years. The dust grains do not just scatter the light, they encode the spectral fingerprints of the star within the reflection, allowing us to study the chemistry of the blast long after the source has faded. It is a harmonious marriage of light and matter that ensures no great event in the cosmos occurs without leaving a lasting impression on the surrounding dark. These expanding rings of light act as a delayed broadcast, allowing astronomers to watch the history of a supernova unfold years or even decades after the initial explosion has faded from view. As the light reaches more distant pockets of dust, it provides a continuous update on the early stages of the blast, serving as a biological record of the star's final moments. This celestial playback is essential for understanding the mechanics of stellar death, as it allows us to revisit events that happened long before modern telescopes were even built. Notice how the rings appear to grow larger over time, mapping out the vast, empty chasms of the galaxy through the simple act of reflection. By following these ripples, we can measure the distances between stars and the density of the intervening mist with incredible precision. The dust provides the screen upon which the most dramatic stories of the universe are projected, turning the cold void into a theatre of light. As you lie still, feeling the gentle rise and fall of your chest, consider how the universe remembers its own history through these silent, dusty echoes. The rings continue to expand long after the original fire has gone out, a quiet and persistent reminder of the energy that once blazed in the dark. It is a beautiful, slow-motion recount of a violent end, softened by the vast distances and the patient grains of ash. Deep within the centres of active galaxies, the environment becomes far more extreme as supermassive black holes are often shrouded in a thick donut-shaped torus of incredibly hot dust. This gargantuan ring of particulate matter serves as a dark, dense veil that orbits the gravitational monster at the heart of the galaxy, sequestering it from the rest of the stellar population. It is a region of intense activity and staggering scale, where the dust is subjected to the overwhelming gravitational pull and fierce radiation of the black hole's immediate surroundings. Surprisingly, the universe uses these dusty tori to regulate the growth and influence of the black hole, acting as a massive reservoir of fuel that is slowly fed into the central abyss. The torus itself is composed of countless individual grains that have survived the trek from the outer galaxy, gathering in a high-density ring that can span hundreds of light years. This structure is a fundamental component of the galactic core, defining the appearance and behaviour of the most powerful objects in the known universe. This dark donut is not a static barrier, but a swirling, turbulent maelstrom of matter that is constantly being reshaped by the energy of the accretion disk. As the dust grains are heated to extreme temperatures, they begin to vibrate and glow, signalling the presence of a hidden giant that would otherwise remain invisible. It is a place where the smallest specks of ash meet the most profound gravitational forces, creating a gateway between the visible galaxy and the absolute darkness of the black hole. This incredibly dense material absorbs the fierce, high-energy radiation emanating from the black hole's accretion disk and transforms it into a steady, intense glow in the infrared spectrum. The dust acts as a massive thermal blanket, catching the lethal X-rays and ultraviolet light and re-radiating that energy as soft, warm heat that can penetrate the thickest clouds. By observing this infrared signature, we can detect the presence of hidden black holes that would otherwise be completely obscured by the very material they are consuming. Notice how the dust serves as a protective converter, shielding the rest of the galaxy from the raw, unfiltered radiation of the core while revealing its location to our senses. This thermal glow is so powerful that it can outshine all the stars in the galaxy combined, making the dusty torus one of the brightest infrared sources in the sky. It is a masterful display of energy management, where the most destructive light is tamed and recycled into a gentle, detectable pulse. Take a slow, deep breath in, feeling the air fill your lungs, and let it out smoothly, embracing the secure and protective warmth of your own environment. This interaction between the black hole and its dusty shroud is a perfect example of how the smallest particles can influence the larger scales of cosmic evolution. The dust is not just a passive bystander. It is the medium through which the energy of the abyss is translated into something we can understand. Surprisingly, the reach of these microscopic grains is so vast that we can detect the faint signature of cosmic dust in galaxies located billions of light years away, existing near the very dawn of time. Even in the universe's infancy, the processes of stellar birth and death had already begun to populate the void with solid matter, proving that the cycle of renewal is as old as the stars themselves. These ancient particles tell us that the cosmos was never a purely gaseous expanse for long, as the first suns were quick to forge the building blocks of solid worlds. If we were to look closer at these primordial systems, we would see a universe that was already rich with the materials necessary for complexity and structure. The detection of dust in the first billion years of cosmic history challenges our understanding of how quickly the first generations of stars could enrich their environment. It suggests that the foundations for planets and life were laid much earlier than we ever imagined, written in the soot of the very first fires. This ancient dust is a survivor of a much younger and more chaotic era, carrying the chemical history of the first forges across the immense span of space and time. It serves as a bridge between the simple hydrogen of the Big Bang and the structured, mineral-rich universe we inhabit today. By studying these distant signatures, we are peering back at the earliest moments of our own heritage, seeing the first grains of sand in the cosmic ocean. The mere presence of dust in these incredibly ancient galaxies proves that the first generations of stars lived, died, and seeded the cosmos with heavy elements incredibly quickly. These primordial giants burned with a fierce intensity, completing their entire life cycles in a mere fraction of the time it takes a star like our Sun to age. They acted as the first great forges, working at a frantic pace to ensure the young universe was enriched with the materials necessary for complexity. Surprisingly, the speed of this enrichment suggests that the universe was biased towards solid matter from the very beginning, transitioning from gas to grit with remarkable efficiency. This rapid turnover created a feedback loop where the new dust allowed for the formation of even more stars, accelerating the evolution of the first galaxies. The ancient ash we detect today is the result of this early, frantic industrialization of the heavens, a record of the first great recycling project. Allow your facial muscles to relax entirely, releasing any tension in your jaw, mirroring the effortless and natural connections happening endlessly in the dark above. This realization shifts our perspective on the early universe, from a barren and empty void to a vibrant and productive nursery that was already preparing for the future. The first stars were the pioneers, sacrificing their short lives to fill the darkness with the dusty seeds of everything that was to follow. Entire galaxies can collide in majestic, slow-motion encounters, causing their internal dust clouds to compress and trigger massive, brilliant bursts of new star formation. As the vast reservoirs of gas and grit from two separate systems intermingle, the resulting gravitational shock waves squeeze the material into dense, fertile knots. This interaction transforms the collision from an act of destruction into a grand, creative event that lights up the darkness with millions of newborn suns. Deep within these colliding systems, the dust lanes are twisted and stretched into long, graceful tails that span hundreds of thousands of light years. These filaments act as the fuel lines for the starburst, funneling the raw materials of the two galaxies into a central region of intense production. It is a spectacular display of galactic alchemy, where the energy of the collision is converted into the physical substance of a new combined system. Imagine looking at the majestic Sombrero Galaxy, which appears perfectly bisected by a sharp, dark lane of opaque dust circling its brilliant and bulging central core. This iconic feature is an immense ring of soot and silicate that stays perfectly aligned with the galaxy's disk, blocking the light of the billions of stars behind it. It creates a striking silhouette that emphasizes the sheer scale and thickness of the material that permeates the spiral structure of the cosmos. This dark band is a visible reminder of the sheer volume of matter that resides in the disk of a galaxy, serving as the reservoir for all future generations of stars. It is so dense and well-defined that it looks like a solid physical structure, a grand cosmic belt that holds the galaxy together in the eye of the observer. Within this lane, the processes of collapse and chemistry are quietly unfolding, far from the brilliant glare of the central bulge. Notice how the contrast between the glowing core and the blackened dust lane defines the very identity of the Sombrero Galaxy, making it one of the most recognizable objects in the sky. This structure is a masterpiece of light and shadow, demonstrating the power of the smallest particles to shape our view of an entire island universe. It is a humble band of ash that commands the attention of every telescope that gazes its way. The intergalactic space between galaxies was once thought to be a completely empty and desolate wasteland, but faint traces of wandering dust have been found even in these lonely chasms. These rogue particles have been cast out of their parent galaxies by powerful stellar winds or the violent tug-of-war of galactic near-misses. They drift in the profound isolation of the deep void, a thin and ghostly bridge of matter that connects the island universes to one another across the infinity of space. Surprisingly, this extragalactic dust is so pervasive that it forms a subtle, invisible web that spans the entire observable universe. Though incredibly diffuse, its collective mass is significant enough to influence the journey of light across billions of light years. It is a persistent and ancient presence, a collection of wanderers that have escaped the gravitational embrace of their homes to wander the great expanse. Take a moment to feel the absolute stillness of your limbs, allowing any lingering tension to dissolve into the surface beneath you as you consider these lonely travellers. They are the most isolated objects in existence, yet they remain a part of the grand galactic cycle, carrying the elements of their birthplaces into the furthest reaches of the void. Even in the most empty places, the dust ensures that the universe remains a connected and material reality. This extragalactic dust slowly dims the light of distant quasars as it travels toward us, forcing astronomers to carefully correct their measurements of the expanding universe. Even a tiny amount of material spread over billions of light years can significantly alter the appearance of the most distant and energetic objects in the sky. This subtle obscuring veil acts as a final filter on our understanding of the cosmos, requiring a deep knowledge of the dust to see the truth behind the light. Deep within our cosmological models, the presence of this dust is accounted for to ensure that we are not misled by the apparent brightness of distant markers. By understanding how the grains absorb and scatter light over vast distances, we gain a more accurate view of the expansion rate and the history of the universe. The dust acts as a master of nuance, adding a layer of complexity to the simplest observations of the deep past. As you remain in this state of peaceful stillness, consider how the smallest grains of ash can influence our understanding of the entire cosmic scale. The journey of light from a distant quasar is a story that is edited and refined by every particle it encounters on its way to Earth. In this grand exchange, the dust remains the final mediator, ensuring that our view of the heavens is always a product of both the light and the shadows. The final mediator of these cosmic shadows is found in the realm of the incredibly small, where the boundaries of matter themselves begin to dissolve into the vibrating patterns of the void. In the deepest reaches of the interstellar medium, the smallest particles of cosmic dust blur the line between solid grains and large, complex molecules known as polycyclic aromatic hydrocarbons. These structures represent a true twilight zone of physics, possessing enough atoms to be considered a solid substance, but few enough to behave according to the strange pulsing rules of quantum mechanics that govern the subatomic world. If we were to look closer at their skeletal architecture, we would see a series of interlocking hexagonal rings made of pure carbon, resembling a microscopic honeycomb or a fragment of fragile graphite suspended in a vacuum. These rings are exceptionally stable and resilient, allowing them to drift through the void for eons without losing their shape or their fundamental chemical identity under the pressure of cosmic winds. They are neither gas nor rock, but a persistent, floating soot that coats the entire galaxy in a layer of ancient organic complexity, waiting to be caught in the light of a new sun. This pervasive presence means that the very air of the galaxy is thick with these nanoscopic flakes, making them a fundamental and inescapable component of the cosmic landscape that we observe from our planet. They act as the vital bridge between the simple elements born in the hearts of stars and the vast solid bodies of the planets that eventually coalesce in the disk. In this microscopic realm, the dust is no longer a passive bystander, but a vibrant chemical participant in the life, motion, and evolution of the entire universe across the span of geologic time. These tiny structures are so small that absorbing a single photon of light causes their entire temperature to spike dramatically, a phenomenon known as quantum heating that defies traditional thermodynamics. Because the grain contains so few atoms, The energy from a single particle of high-energy ultraviolet light is enough to send the entire structure into a frantic, high-frequency vibration. On a macroscopic scale, this would be equivalent to a single drop of warm rain causing an entire mountain lake to instantly boil and then rapidly cool in the blink of an eye. In the cold, profound isolation of the void, this sudden thermal surge is a violent departure from the near absolute zero environment of the surrounding molecular cloud. The grain does not remain hot for long, as it immediately begins to shed this excess energy by radiating it away in a characteristic soothing infrared glow that permeates the darkness. This process happens trillions of times every second across the spiral arms of the galaxy, creating a subtle, thermal heartbeat that can be detected by our most sensitive space telescopes. This stochastic heating is a uniquely quantum behavior where the temperature of a particle is no longer a steady state, but a series of sharp, jagged peaks separated by long periods of frozen silence. It demonstrates how, at the smallest scales, the traditional laws of physics are replaced by the unpredictable and energetic exchanges of the subatomic world. The dust grain becomes a tiny individual laboratory for testing the limits of how matter handles the raw, unfiltered energy of the most massive stars in the heavens. This quantum heating process results in the emission of a unique, continuous spectrum of warm infrared bands that are found in almost every corner of the observable galaxy. These spectral features are so distinct and pervasive that for years they were known as the unidentified infrared bands, a deep mystery that puzzled astronomers for decades before the role of carbon rings was understood. We now know that they are the specific vibrational signatures of the carbon rings, singing their own unique song as they cool down from their sudden thermal spikes. The glow of these bands provides a pervasive, warm luminescence that fills the gaps between the stars, even in the coldest and most lightless molecular clouds of the galactic plane. It is a soft, comforting radiance that acts as a thermal signature for the entire interstellar medium, revealing the presence of hidden matter where we once saw only empty space. By mapping these specific frequencies, we can trace the distribution of organic material across the entire majestic structure of the Milky Way and beyond. Surprisingly, this emission is so widespread and intense that it represents a significant fraction of the total infrared light produced by our entire galaxy. It is a massive collective effort of trillions of microscopic particles, each contributing its own tiny pulse of energy to the grand infrared glow of the cosmos. This infrared chorus is the true voice of the dust, telling the eternal story of the constant and necessary exchange of energy between light and matter. Deep within the harsh and unforgiving environment of interstellar space, these resilient carbon rings survive where more delicate molecules are torn apart by the relentless bombardment of high-energy radiation. The aromatic structure of these rings provides a unique level of electronic stability, allowing them to absorb and distribute energy without breaking their fundamental chemical bonds. They are the ultimate survivors of the void, enduring extreme conditions that would quickly sterilize and destroy almost any other form of complex organic matter. As you rest here, feel the steady, unmoving weight of your own existence against the surface beneath you, a point of stillness in a galaxy of vibrating atoms. This stability is the primary reason why these grains are so pervasive, accumulating over billions of years to form a permanent and ancient reservoir of carbon in the interstellar medium. They act as the rugged ancestors of all complexity, holding the line against the destructive forces of the stars until a more stable environment can finally be found. This resilience ensures that the essential building blocks of chemistry are never truly lost to the void, but are instead carried forward from one generation of stars to the next. The dust grains are the enduring memory of the galaxy, preserving the carbon forged in ancient supernova and red giants within their unbreakable and vibrating rings. They are the sturdy, invisible skeletons of the cosmos, providing a permanent foundation for everything that is destined to emerge in the future. Notice how these complex organics represent a crucial stepping stone between simple gases and the building blocks of life, bridging the grand gap between the atomic and the biological. By organizing single atoms into complex, stable rings, the dust grains provide the necessary physical complexity for the next stage of chemical evolution to take hold. They are the essential intermediate step in a grand, universal process that turns the raw elements of the Big Bang into the intricate chemistry of a living cell. Surprisingly, these molecules are found in high concentrations in the very regions where planets are actively forming, ensuring that every new world is seeded with organic potential from the moment of its birth. They provide a ready-made source of complex carbon that can be effortlessly incorporated into the chemistry of a nascent atmosphere or a growing primitive ocean. This chemical legacy means that the possibility of life is not a local accident, but a universal feature written into the very dust that fills the galaxy. This cosmic progression suggests that the universe is inherently biased toward complexity, using the simplest materials to build the most intricate and beautiful structures. The dust is the patient mediator of this transition, acting as the quiet architect of the organic world, while the stars continue their fiery work in the background. It is a beautiful, seamless journey from the heart of a dying star to the surface of a habitable planet, guided by the tiny hands of these microscopic grains. The edges of glowing emission nebulae are dominated by the bright specific glow of these nanometer-sized carbon flakes, outlining the borders of stellar nurseries with a ghostly light. As the intense ultraviolet radiation from newborn stars slams into the surrounding molecular clouds, it first encounters these tiny quantum grains at the boundary layer of the nursery. This interaction creates a vibrant, glowing shell that marks the transition between the empty void and the dense, star-forming gas that hides the future. If we were to look closer at these regions, we would see a chaotic but beautiful battleground where light is being converted into heat and chemical energy with remarkable efficiency. These boundary layers, known as photon-dominated regions, are the most active and vibrant parts of the nebula, where the chemistry of the entire cloud is being reshaped by the star. The dust grains are the primary actors in this celestial drama, absorbing the brunt of the radiation and protecting the fragile interior of the cloud. This specific glow acts as a brilliant beacon for astronomers, allowing them to map the precise boundaries and internal structures of distant nebulae with incredible and unprecedented detail. The light of the grains reveals the hidden geometry of the nursery, showing us the ridges, valleys, and hollows carved into the gas by the intense stellar winds. It is a visual masterpiece that highlights the delicate balance between the destructive power of the stars and the protective presence of the dust. As these tiny grains erode under the constant pressure of intense starlight, they gradually release single carbon atoms and small molecular fragments back into the gaseous void. This process, known as photodestruction, is a slow and steady wearing away of the solid structure, returning the elements to their simplest and most fundamental form. It is the final stage of the dust grain's long life cycle, where it gives up its solid identity to fuel the next cycle of galactic chemical reactions. Surprisingly, this erosion is a crucial and continuous source of free carbon in the interstellar medium, providing the raw material for the formation of even more complex molecules. The dust grain does not simply disappear into nothingness, but is instead recycled into the next generation of matter, ensuring that nothing in the universe is ever truly wasted. This constant turnover maintains the chemical vibrancy of the entire galaxy, keeping the elemental reservoirs full and ready for the next act of creation. This cycle of assembly and destruction is the heartbeat of the galactic ecosystem, a continuous process of renewal that has been unfolding since the very first stars ignite. The dust is the medium through which this recycling occurs, acting as both the vessel and the fuel for the grand cosmic furnace that powers the stars. In this exchange, the slow death of a single grain is the necessary and poetic precursor to the birth of a brand new chemical possibility. Picture these quantum grains as tiny antennas, perfectly tuned to catch the specific frequencies of ultraviolet energy, and broadcast it back as a gentle warmth into the void. Their physical size and chemical structure make them exceptionally efficient at interacting with the light produced by the most massive and energetic stars in the entire galaxy. They act as the universal receivers of the cosmos, capturing the energy that would otherwise be lost to the infinite and empty expanse of space. Let your shoulders drop and your jaw soften, becoming as still and receptive as a grain of dust suspended in the quiet, dark currents of the interstellar medium. This conversion of energy is what maintains the overall temperature of the galactic gas, preventing the clouds from freezing into a completely static and inert state. The dust ensures that the galaxy remains a dynamic and active environment, where the energy of the stars is shared with the cold and lonely surrounding void. Without these microscopic antennas, the universe would be a much colder and more stratified place, with energy being trapped only in the immediate vicinity of the massive stars. The dust acts as a cosmic radiator, distributing the warmth of the stellar population to the furthest and most isolated reaches of the spiral arms. It is a harmonious and efficient system of energy management that allows the entire galaxy to function as a single, vibrant, and interconnected entity. Their distinct chemical signatures have been found everywhere, from the most distant galaxies at the edge of the observable universe to the meteorites that occasionally fall onto the Earth. This universality proves that the chemistry of the carbon ring is a fundamental feature of the cosmos, appearing wherever the conditions for stellar birth are met. Whether it is in the heart of a primordial nebula billions of years ago, or the surface of a local asteroid today, the dust remains essentially the same. This persistent presence in meteorites provides us with a tangible and direct link to the earliest history of our own solar system, preserving the organic matter of the pre-solar cloud. These grains have survived the violent birth of the sun and the long formation of the planets, carrying their ancient secrets through the dark and into the palm of our hands. By studying these fragments, we are literally touching the same material that once drifted through the most distant and ancient galaxies of the early universe. Notice how this chemical thread links our local, solid reality to the furthest and most ancient reaches of space and time, creating a sense of unity across the entire cosmic scale. The dust is the common language of the universe, a material that is as familiar in a distant starburst galaxy as it is in our own quiet backyard. It is a humbling and profound realization that we are made of the same resilient and vibrating soot that fills the deepest and most isolated chasms of the void. The study of these ultra-small grains forces astronomers to blend the grand scales of astrophysics with the complex and tiny rules of quantum chemistry, revealing a universe governed by the laws of the very small. To understand the glow of a distant and majestic nebula, one must first understand the vibrating bonds of a single carbon molecule and how it responds to a single photon of light. This interdisciplinary approach is the only way to truly unravel the mysteries of the dust and its fundamental role in the evolution of the galaxy. This structure of knowledge bridges the gap between the controlled laboratory on Earth and the massive telescope looking into the dark, where the behavior of microscopic particles informs our understanding of the larger structures. It is a beautiful and necessary collaboration, where the secrets of the atom are used to unlock the secrets of the stars and the galaxies. The dust grain is the ultimate synthesis of these two worlds, a physical object that requires both sciences to be fully and truly understood by our minds. Ultimately, the quantum grains remind us that the most significant and profound processes in the universe often happen at the smallest possible scales, hidden from the naked eye. They are the quiet, vibrating heart of the cosmos, the final and most delicate mediators of the grand exchange between light and shadow. As we look at the stars, we're also looking at the result of 1 trillion tiny quantum dances that have been unfolding since the very beginning of time itself. These quantum dances are the prologue to a much larger circular odyssey that transcends the lifespan of any single star in the great celestial disk. Every microscopic grain of matter is a seasoned traveller, caught in an eternal loop that carries it from the scorched, turbulent heart of a dying star into the freezing, expectant cradle of a new world. This journey is not a straight line toward a final ending. but a recurring theme in the music of the spheres, where every departure is a necessary preparation for a later arrival. Imagine the grain drifting through the lightless corridors of a molecular cloud, a tiny vessel of solid history navigating the immense currents of the interstellar medium. It carries within its structure the secrets of a sun that flared and faded long before our own planet was even a glimmer of possibility in the dark. This motion is as natural and inevitable as the slow, deep release of air from the lungs, a peaceful transition from the intensity of stellar life to the quiet potential of the void. As the grain moves, it experiences the profound stillness of the deep vacuum, where time seems to stretch and thin like a translucent veil over the face of eternity. It is here, in the cold and the dark, that the grain finds its true purpose, acting as a seed of stability around which the chaos of gas can begin to coalesce. The cycle remains unbroken, a testament to the persistent and patient nature of a universe that never truly discards its most humble components. While much of the dust we observe is ancient, our galaxy is never stagnant, constantly replenishing its reserves with fresh material forged in the most extreme environments imaginable. The violent cataclysmic eruptions of supernovae act as a sudden, forceful exhale, blasting newly minted elements into the surrounding space at incredible velocities. These explosions are the primary foundries of the heavy elements, showering the galactic arms in a rich metallic rain that will eventually settle into new forms of complexity. In contrast to these sudden bursts, the aging red giant stars provide a more measured and graceful contribution to the cosmic reservoir. These bloated, cooling suns shed their outer layers in a steady rhythmic sigh, allowing the newly synthesized carbon and oxygen to condense into solid grains as they move away from the heat. This process is a gentle, continuous replenishment, ensuring that the interstellar medium is never depleted of the essential building blocks required for future generations of stars. This fresh dust is the raw, unrefined currency of galactic evolution, possessing a purity and energy that has not yet been tempered by the long ages of the void. It mingles with the older, weathered grains, creating a diverse and complex mixture of matter that reflects the history of countless stellar lifespans. The sheer scale of this production is a reminder that the universe is a living, breathing system, always creating even as it consumes. This continuous recycling of stellar material acts as a profound enrichment process for the entire interstellar medium, functioning much like the slow build-up of fertile soil on a forest floor. Each new generation of stars is born from a gas that is slightly more complex and metallic than the one that came before it, thanks to the contributions of those that have already perished. This galactic metallurgy ensures that the universe is constantly evolving away from its simple, hydrogen-dominated beginnings toward a more diverse and intricate chemical state. As the heavy elements accumulate, they change the very nature of how stars form and how they radiate their energy back into the darkness. The presence of these grains allows the gas clouds to cool more efficiently, which in turn leads to the formation of smaller, more stable stars that can burn for many billions of years. This enrichment is the silent engine of progress, providing the necessary materials for the universe to build more than just giant balls of fire. Notice how the life cycle of dust perfectly mirrors the broader, majestic life cycle of the entire universe as it moves toward greater organization. As you rest here, feel the steady, unmoving weight of your own existence against the surface beneath you, a point of stillness in a galaxy of vibrating atoms. This stability is the result of countless cycles of enrichment, a long and patient process of refinement that has been unfolding since the first light pierced the darkness. Surprisingly, the very existence of a solid terrestrial world is a direct consequence of this gradual and painstaking build-up of cosmic soot across vast stretches of time. In the earliest ages of the galaxy, the environment was thin and poor in the heavy materials needed to construct something as substantial as a mountain or a canyon. The first planets were likely gas giants, massive and ethereal bodies that lacked the rocky core and stable surface that we find so familiar on our own world. It took many generations of stars living and dying to produce enough solid debris to allow for the accretion of rocky planets. Each grain of dust that participated in the formation of the Earth was once a part of a larger, grander story, contributing its tiny mass to the eventual creation of a place where life could finally take root. The solid ground we walk upon is actually a collection of recycled stardust, compressed and transformed by gravity into a permanent home. Without the persistent, patient recycling of these heavy elements, the universe would remain a realm of light and gas, beautiful but fundamentally incapable of producing the complexity we see today. The rocky planets are the solid proof of the galaxy's long-term memory, built from the refined remains of 1,000 previous stellar generations. This transition from the ephemeral to the permanent is the true miracle of the dust, turning the ghostly echoes of dead stars into the ground beneath our feet. Deep within the spiraling architecture of the galactic disk, immense dust lanes act as sweeping cosmic brooms, gathering wandering gas into dense and vibrant ridges. These lanes are the primary sites of star formation, where the steady pressure of galactic rotation forces the interstellar medium into concentrated pockets of potential. As the dust gathers the gas, it creates a sanctuary of shadow, where the heat of distant stars cannot penetrate, allowing the cold to do its work. If we were to look closer at these ridges, we would see a chaotic but beautiful process of organization, where the dust acts as a catalyst for the collapse of giant molecular clouds. The grains provide the necessary surface area for chemical reactions to occur, helping to build the complex molecules that will eventually populate a new solar system. This gathering of material is the essential first step in the creation of a new stellar nursery, a concentration of energy that will soon ignite. This sweeping motion is a rhythmic and predictable feature of the galaxy, ensuring that the fire of creation is always being rekindled in new locations. The dust lanes are the veins of the galaxy, carrying the lifeblood of the cosmos to the regions where it is needed most. It is a harmonious and efficient system of resource management that allows the galaxy to maintain its youthful vitality, even as it grows older. The delicate and ever-shifting balance between the creation of new dust and its inevitable destruction governs the overall evolution and appearance of every galaxy in the universe. In young, vibrant galaxies, the rate of production is high, leading to a landscape filled with dark shadows and bright glowing nurseries. In older, more elliptical galaxies, the dust has been largely consumed or dispersed, leaving behind a clear and static population of ancient stars. This balance acts as a cosmic thermostat, regulating the rate at which new stars can form and the way that light is distributed throughout the galactic structure. If too much dust is destroyed by the intense radiation of massive stars, the galaxy loses its ability to cool and create, leading to a period of dormancy. Conversely, a surplus of dust can shield too much light, creating a cold and dark environment where the fires of fusion are slow to ignite. The presence of dust is therefore the primary indicator of a galaxy's health and its capacity for future growth. By observing the distribution of these grains, we can determine the history of a galaxy's star formation and predict its future trajectory across the eons. It is a beautiful and complex dance of matter and energy, where the smallest particles dictate the fate of the largest structures in existence. Imagine a single atom of silicon, a tiny and indestructible witness to the passing of millions of years within the protective shell of a solid dust grain. This atom may have spent an eternity drifting through the lonely gaps between the stars, shielded from the harsh radiation of the void by the surrounding layers of ice and carbon. It is a passenger on a journey through deep time, waiting for the moment when the grain is finally pulled into the gravity of a developing solar system. Eventually, the heat of a new sun or the chemical activity of a primitive planet might vaporize the grain, releasing the silicon atom into a new and vibrant environment. It might find its way into a cooling magma flow, becoming part of a crystalline rock, or it could be absorbed into the rich, chemical soup of a nascent ocean. From there, the journey takes a remarkable turn as the atom is incorporated into the delicate and complex machinery of a living organism. This atom does not know its own history, yet it carries the mark of the stars in its very nucleus, having been forged in a furnace far more intense than anything found on Earth. Its presence in a living thing is a bridge between the biological and the celestial, a reminder that the boundary between the living and the non-living is often just a matter of arrangement. The silicon atom is a permanent citizen of the cosmos, temporarily on loan to the world of life, before the cycle eventually claims it once more. The very calcium that gives strength to our bones and the iron that carries oxygen through our blood travelled through this same dark, dusty phase before settling on our ancient Earth. These elements were not created in our solar system, but were delivered to us across the vast distances of space, carried by the very grains that we now study with our telescopes. We are, in a very literal sense, the children of the interstellar medium, built from the debris of stars that vanished long ago. As you sit in this moment of quiet reflection, notice how your own breath falls into sync with this cosmic rhythm, a steady and peaceful exhale that mirrors the dispersal of matter. This physical connection to the stars is not a poetic metaphor, but a biological fact, written into the very chemistry of our cells and the structure of our DNA. Every beat of your heart is powered by the energy once trapped in the core of a distant sun, released and recycled through the patient medium of the dust. This realization brings a sense of profound unity to our understanding of the universe, erasing the distance between the human experience and the cold reaches of space. The dust is the medium that links the macrocosm to the microcosm, ensuring that the legacy of the stars is preserved within the bodies of the living. We are the universe observing itself, using the refined material of 1 billion years to contemplate the very process that brought us into being. Notice how the life cycle of a single dust grain perfectly mirrors the broader, majestic life cycle of the entire universe, following a pattern of expansion and contraction. Just as the grain is born in fire, wanders in the cold, and is reborn in a new star, the universe itself moves through phases of creation, dispersal, and reorganization. This fractal nature of the cosmos ensures that the same fundamental laws apply at every scale, from the subatomic to the galactic. The cycle of renewal is the ultimate insurance policy for the universe, ensuring that energy is never truly lost, only transformed into new and more interesting states. It is a story of persistence and resilience, where even the most destructive events are used as a catalyst for a new beginning. In this grand perspective, the death of a star is not a tragedy, but a necessary exhale that allows the universe to take its next, deep breath. As we point our most sensitive telescopes toward the distant glowing clouds of the galactic plane, we are literally watching the endless, patient recycling of the cosmos in action. These images are not static portraits of a finished creation, but snapshots of a work in progress, where the breath of the universe is visible in every swirl of gas and every shadow of dust. We see the slow, rhythmic expansion of nebulae and the bright, energetic birth of stars, all part of a single coherent process. This observation is a deeply humbling experience, as it reveals a universe that is both vastly larger than our own lives and intimately connected to our own physical existence. The glowing clouds are the nurseries of the future, holding the raw materials for worlds that will not be born for another 1 billion years. By studying the light and the shadows, we gain a perspective on time that is measured not in years or centuries, but in the long, slow breaths of the stars themselves. Deep within the silence of this final realization, we find the ultimate truth that the universe does not just contain a cycle of renewal, but is the cycle itself. Every breath you take is a continuation of a story that began in a distant nebula and will continue long after the stars we see tonight have faded. This last wonder is the simple, profound understanding that you're not merely watching the cosmos, you are the cosmos expressing its own eternal return. If we were to look closer at the tips of your toes, we would find the same stillness that exists in the heart of a molecular cloud. Let the muscles in your feet and ankles soften. releasing the day's journey into the supportive surface beneath you. Each cell is a tiny reservoir of history, resting now after a long and ancient trek through the dark. Surprisingly, the body knows exactly how to settle into this state of profound equilibrium, drawing on a wisdom that predates the very earth. Feel the heavy, warm relaxation spreading through your legs and into your hips, anchoring you to this moment of absolute peace. The structural elements that support you are now at rest, their work of holding the world together complete for the night. Notice how your breath moves with the same effortless grace as the expanding and contracting tides of a distant galaxy. Let your fingers curl naturally, losing their grip on any lingering thoughts or tasks as the torso sinks deeper into the mattress. The center of your being is a place of quiet radiance, where the energy of the past is stored in perfect, motionless silence. This quiet room is a sanctuary of soft shadows and cool, still air. The mattress beneath you is a firm and steady presence, absorbing every bit of tension left in your shoulders and neck. You're perfectly safe here, enveloped in the gentle embrace of the blankets and the rhythmic sound of your own breathing. The air in the room is thin and sweet, carrying the scent of rest and the promise of a long, dreamless night. Let your jaw soften completely, allowing the tongue to rest away from the roof of the mouth as your face becomes a mask of total calm. Each slow, deep exhale is a signal to the mind that it is finally time to let go and disappear into the darkness. The silence is a thick velvet blanket that covers every corner of the room, muffling the world outside until it is nothing more than a memory. Your breath is the only sound, a steady and comforting movement that carries you further away from the waking world with every passing second. You're submerged in the peace of this moment, floating in a sea of absolute stillness and warmth. Everything is quiet, everything is still, and everything is exactly as it should be. The day is done, and the night has arrived to guide you into the deepest parts of sleep. And now, 101 wonders are resting with you. Sleep now. Good night.